them
matter.
on.
Doesn't
I
matter to
thought
me,
it might
but-
help people that. Well, okay. Well,
Keep it.
Yeah, I don't care. Leave
I'm
it.
going to keep it on. I like having.
That's fine. All right.
Converge together, but you can see that there is two celestial discs spinning in the sky. You can see that there is no way to get around the whole point that it literally works off of a magnetic flow, just like your compass works off of a magnetic flow. Two discs that are connected together with a 15-degree, as far as, I shouldn't say 15-degree, they're connected together as far as from pole to pole with a magnetic flux. You can literally measure it with your compass.
With the magnetic declination, people are so convinced that it must be one pole because the magnetic declination seems to be showing that somehow for them.
Well, no, they think of it as a ball, or I don't know why they think. Oh, you're talking about the whole AE map, one pole.
Right.
I don't know. It doesn't make any sense to me why they don't see that the actual flux of what you're coming through. Even though, let's say this is North Pole and this is South Pole. Let's say you're traveling from Alaska, however you want to put it, Alaska down to Antarctica, right? As you get there, it's not that it's pulling to the south, it's just pulling along the magnetic north lines.
Okay,
So
yeah, so that's the answer right there. It goes north to south, so it can give you that illusion regardless. I mean, south
yes,
to north.
but it only your compass only goes to the north. It doesn't go to the south. That's
Yeah, that's
a
what people are
misconception.
confused on. They think there should be a compass that if you reversed the compass, you should be pointing to the south, and it doesn't work that way.
No, it does not work that. Not even close. You guys think of it as you've got magnetic flux running around a wire, and that's just how it works. I mean, there's just a rule of thumb. You grab onto that wire. If positive is this way, or the current through the wire is going this way, when you grab, the rule of thumb would say that your magnetic flux is going to spin around it in a counterclockwise motion. You literally have a current or a wire bent over, and that gives you exactly what we have here in the sky. And I'll show you that here in just a second. As far as
Well,
you
you're
can
not
see
trying
that
to say
on
there's
the,
literally a wire. You're saying that it works just like this would, even though you don't know what
I'm
it
saying
is,
there's a
how
connection.
it's constructed necessarily.
I'm just saying there's a connection. So the sky is the connection. The whatever you want to say, however, that there is a connection between here for the toroidal fields. Literally, two toroidal fields that run on the same principle of a magnetic field running from a wire, having current run through it. You get a magnetic field that runs like that. If you take that same wire and bend it over, this is what you get. You would get one magnetic field moving in one direction, because if you're spinning this way and I bend that over, you're spinning like this. You see?
Yeah.
It's the same
image.
way.
All right, so like he's saying there's not really a connection there, but it's as if there is a connection there, right?
We can't know what the connection is, but it works just like this does in real life. Like
Gotcha.
electromagnetic field works that way.
I was just making sure I didn't miss anything. I'm gonna.
Yeah, he was saying it's like it's literally a wire, but when he says literally, I wanted to make sure he wasn't trying to say he thinks there's a wire there, because who knows how it works necessarily, but it worked like this, like if you were to do a wire with the way this works. And it's flipped over.
Right.
I just said mirror image, and he's about to correct me, but
I got you.
it's like it's a flipped image.
Yep. It's not a mirror image. No, it's
a flipped
it's
image.
There you go. It's just a bent over, like a branch bent over. But then now you can see that you get the fields of there. And there is no doubt the shape that we're getting, or the shape you're seeing anyway, the movement of the iron filings looks as the exact same as what you get in the sky. As you go out to the sky, look, and you literally have an electric universe sitting above you. And that's how we use and use compasses on the world, or in the world, with magnetic
field lines.
latitude, longitude. I mean, that's exactly how we
Well,
do it.
there's your
So
longitude,
then,
right? The magnetic field lines would be your longitude, and then the star fields would
just
be your latitude.
just just the longitude, as far as that.
Yep.
Yeah, the magnetic field lines just allow you to be able to do the longitude. Then you look at the electromagnetic fields, and that's this field right here. So you can see the actual field, just like you could see with the iron filings with the other one. You can see that magnetic field, which is the exact same thing that you see in the sky with the stars.
Yep.
So that's how you get to measure this star right here. And no matter where you are, if you're in the northern plane and you measure that star right there, that gives you your latitude as far as which line you are on here, depending on where you are as far as that goes.
So people are always saying Pac-Man sun, or that, that how is it going straight across the celestial equator if you're saying it's looping around the donuts and all that?
Okay, so if you got to look at these lines right here. I'm going to take away the longitude lines so they just don't mess with us. So you can still see where the longitude or latitude lines are. That would mean that this is 1 degree latitude. Now this map's not perfect, guys. This isn't great and everything in the sun. Let's say on March 21st, or let's just go with the summer. In the summertime in the United States, it's going to be 23 degrees up. It's going to circle 23 degrees. So if that's 15, that's 30. It's going to be just on that side of that line, circling all the way up, all the way around, all the way around. That's going to be 1 day.
Yep.
Okay? On March 31st or March 21st, it would literally go like this. From here, it would go. That would be 1 day, but it's going to cross and go down here that day. So if it rides on the one line, it's going down here and crossing over to the one over to the south.
Well, that's when it's discharged the exact amount to be falling to the south for the winter solstice.
Yeah, halfway. It'll be halfway discharged to cross over to the bottom toroidal field, but it'll be 1 degree south, and then they'll go all the way around here 1 day, then it'll be like 2 degrees south, 3, 4, 5. As it goes up, it'll just keep going around a circle till it gets to 23 point. I'm opening things. Sorry, hold on.
All right. Now, if you add the after this, add the longitude back in to show how the sunlight is pulled by the magnetic field as it goes around. Because a lot of people are saying, "Oh, in the south, how are you getting enough sun in the summer and in the wintertime for it to be nice in California still?"
Let's say that my finger tips the sun as it comes around, right? If it's going on the central celestial equator, and let's say it's just on the one, it's going to we're going to have it turn around the north just to make it to where it's not just going to go Pac-Man and go off the screen, because that's not what it fucking does. A lot of people are talking about it being like that for a 2-pole system, and it doesn't. It literally picks one way or the other, and it does it exactly on the same day every single day from time immemorial, March 21st and September 21st. It switches from here and it switches from here as far as on those days. But if it's going across, your sun's literally going to be in a butterfly wing. I can't do it really.
It spreads out as it goes through. Yeah.
Just as you see this line here is how the shadow or the corona of the sunlight's going to be coming in. You're literally going to see that shadow come out like this, and it's going to go, as far as it's going to be a huge, like almost like an axe end looking out there, from here to here, and it's going to crush in or concave, or not con.
No, don't say concave. No, but
convex.
It's convex. Yeah, right.
It's convex. It's going to convex from these latitudes or these longitude lines to right here, to where you get a 12,400 degree corona from the sun, or 12,400 mile corona. So it's a little bit past the north, it's a little bit past the south as it goes across. Let's say the sun's right here where this finger is. So you've got light going all the way across here, and as it hits here, it spreads out.
Right.
And it just follows the magnetic declination of the latitude lines. It's not that it follows the lines or it follows anything. It's just following the actual magnetic field.
line.
That's all.
Yeah.
That's all it's
Right. So
doing.
it spreads out. It spreads out, and the weather conditions for like California are also because of the wind patterns and the oceans.
Not wind patterns, magnetic field. It's literally the magnetic field, because if you watch, um, all weather patterns all around the north literally run around in arms and waves. So you'll have
Uh-huh.
5-pointed star always, of
Uh-huh.
waves of comes this way, goes
Uh-huh.
around. The weather always goes backwards this way. Weather always goes backwards this way
It's almost like
on
the
the
sun's
south.
pushing it away. Like the sun's pushing all of the weather behind it, the opposite direction.
Not pushing, it's the heat, the heat rising or the cool air falling is
The
what's
pressure,
moving.
yeah, causes a
Yeah.
pressure gradient. Yeah.
Yep. Temperature differential. Yep.
Yep. Like there's a lot of conditions. Why is it so nice in California if the sun's in the south so far in the wintertime? How is it still so nice in California? And you were saying it has something to do with the oceans and all those kind of things as well.
Well, yeah. So if you think about, it's different as far as the wind flow and the uh, what you would call the atmospheric pressure. So
Yeah.
you have a lot of atmospheric pressure as far as right around in here, but you also have a lot of wind. So you're not going to get, like, let's say all of Nevada, Utah, even Kansas and stuff. It's really dry and really, really hot and everything, right? But
Hmm.
California is still on the exact same latitude as far as the way everything is. It should be the same thing, but you have that pressure gradient of the water and the
The
high
heat.
altitude pressure dome or whatever you're calling it, and it
Mhm.
literally makes it a temperate climate right along that edge of those mountains that are sitting there. There's two toroidal fields sitting on top of these. As you can see here, if you think of this as the North Pole, this is the South Pole. This represents the North Pole up here. This represents the South Pole down here. But the sun only goes to 23.6 or 23.4 whatever 5, 23.45 south. So it never gets to the inside of the actual toroidal field. So this is the best I could do as far as a toroidal field, to show you two toroidal fields sitting on top of two other toroidal fields. So the ground level would be here. This would be the
Is everyone up to speed? I got to be honest. I kind of got a little lost personally.
You want to go back?
Well, I want to field for in inquiry, because this is only a 20-minute video. So, I mean, we can do
What do
that.
you want to? What do you want to ask, or do you want to? I mean, you said you're lost. Like, what do you? What'd you miss, or what? Do you want to go back and I don't know what to do.
Okay. Well, the thing I'm stuck on is, I mean, he's talking about how the light kind of splays out. Let's see here real quick.
to the temperate climate right along that.
Yeah, he's like basically here, and he says that on March 21st, December 21st, or maybe it's a couple
No,
frames before this, but
no, September
I'm sorry.
21st. When it's halfway discharged on September 21st, it drops down to the south, or down in quotes, because there's no down or up or anything. It's just the way you're looking at it. But if there's two toroidal fields and it's circling the toroids, 182 days it circles around the north until it's halfway discharged, and exactly on September 21st at 6 p.m. it'll cross over the celestial equator and start circling the south for 182 days until it charges back up enough on March 21st at exactly 11 a.m. It crosses over the celestial equator again and starts circling the north for the summer. And you can look up in an article on that. That's where the sun crosses the equator, or in the ball interpretation, that's when the ball would be tilting to the sun, uh, where the equator is on the other side of where we would see the sun, depending on your interpretation. But the ball doesn't work, so it's just a matter of figuring out how it works over the flatland. And the GPs say it crosses over on exactly that time, like exactly to the hour, like at 11 a.m. on March 21st, it goes up to the north, and exactly at 6 p.m., it crosses over on September 21st. And you can look that information up, and it does that. It does exactly that.
So, are you saying that it's I think it's the Tropic of Capricorn, the southern tropic, right? You're saying that is the only one, or just please explain where is the equator in this, or is it just one direction or the other?
Yeah, there is no sun equator that goes around the ball. That's the trick. The sun never goes around the ball. You know why? Because we're not on a ball. The sun either
Well, no,
goes
like
north or south.
equator means like centered, like in the middle. But in
Yeah,
this,
it never runs down. If you could look up the nautical information, the center, the celestial equator line would be 0 degrees. And they never have the sun on 0 degrees ever. It's either a little bit north of it or a little bit south of the equator. It never actually is even plotted to be on that center line. It's either in one lane or the other. And you could say then there's like two sun equators if you want to call the line the sun follows equator. And that equator either runs north in the winter, north in the summer or south in the winter. And it goes two different directions. And that's been the trick the whole time. It never goes around a ball. It never goes straight across. It's never even on that center line ever.
so the trick is that there is no equator.
There is no sun equator. There's a celestial equator, and that celestial equator is where the two star fields meet. That divides the north from the south.
All right.
But the sun going around, like when you see real quick, if you see the blue side of the ball, like when you see the globe they show us, and that whole side is water. You got one whole side where there's no continents and it's all water. That's the trick. That water surrounds all the continents, and the sun goes either north or south and goes around the poles still, just like it does in the ball model. They have the ball tilting, and then they just say that we're tilting and spinning, and the sun, but the sun still has to travel across that whole side of the blue side of the ball in the ball model. And that's why they are tricking us into thinking it goes in a circle around that blue side of the ball, but it just goes either north or south. And that's why we have shorter days in the winter in the north, because it's going south, even though we're getting, still day and night because you can see the sun. It's not like it's you can't think of it linearly, like it's a 2D image where you have to look across all the continents to see the sun, because 2D, it looks like it's way down there. It's still way up in the sky, but it's just way south of us, and we can still see it. We still get day and night. It's just shorter days and colder winters, obviously, because that's what happens, right? Anyway, this is
Colder
interesting.
days, colder winters. Well, okay, when you say
cold
that,
in
that's
the
not the
winter,
only thing I
shorter
experienced
days.
though. Like I experienced that the angle of the sun comports with like a linear sky. So like you can track like a straight line across the sky that represents like the celestial sphere. Like if we're rotating, everything streaks across the sky equally like a line.
Yep.
So I see this. All I notice, all I observe is the sun being at a completely different angle due to it being at the furthest
further
tropic,
south.
and that angle that angle it comports with the amount expected to be further away would drop lower. Now, obviously, it would drop lower if in any of these models, but like I'm trying to justify why it would be that much further away and why it only looks like a line from my POV.
Well,
I'm just
if it
trying to
goes down the
justify
center,
it because
Well, when you see the star fields, the way that they pinch together, I guess. So if we're looking at an electromagnetic field, right? The stars run parallel to each other in what seems like a perfectly straight line across the celestial equator. And they're going straight across, right? And then when you look at the time-elapse photography, you see that they go straight across the center, and then they spread out from each other and go their opposite directions, and then circle around and come straight across the center. Well, the sun does the same effect. It's a little bit either north or south of that equator line. Even according to the nautical information, it's never on that center line. But when it's a little bit south of it, you're going to see it bend. You're going to see it go straight across still, even in North America. You're going to see it go straight across, but it's just lower in the sky and south, and it bends south when it sets. And then in the summer times, it bends north. And that's something you don't have to go to Antarctica to see that. Anybody can observe that the sun sets south of west in the winter and north of west
But
in the summer.
You're
That's
saying
something
it
anyone
bends
could just go out
south.
any day. Yep.
Is there any like celestial refraction or any kind of like bending of light kind of thing in this model, or is it all just
Yeah, he was just talking about that. Like
point
the
source?
electromagnetic fields
Okay.
bend the light. The electromagnetic fields have a direct relationship with the light. It spreads the light out, so you get like still the day and night everywhere. That's what he was just talking about. The electromagnetic fields
Right.
spread the light
Right.
out,
I did
and
hear
then
that part.
when it goes in between the poles, it condenses the light. It's like the way the electromagnetic field would work with something of this sort. It would between the poles, it would condense the light into basically a ball type spotlight, and then as it comes out, the electromagnetic field lines bend, so it bends the light all and spreads it all out. It's like the perfect little machine atrium. If this is correct, I mean, it's like someone built this to like make sure everywhere was the proper amount of light for winter and summer to happen.
Yeah. Okay. It's tough. All right. I want to
Yeah, I
continue
know.
though.
I know
We've
it's
been going
tough.
on this for a second.
It's not like he's just making this up to try to fit his model. He just thinks this seems to be the way it works, and he does have a knack for electromagnetic type stuff. He's the kind of guy that like I was saying, he takes something apart and try to put it back together without looking at any manuals, without listening to what anyone else says about it. And that's what he did with all this information. He just like took what we have, looked at all the bare bones information, and plotted all the stars onto like a custom star wheel map, and saw that the GPS are actually lining up where the GPS should be in the south and the north. Customize it using like the Weems and Plath like official star finder wheels, and those even show you, even though it's on one side or the other, those will show you the stars converge and diverge, and we can see that in the sky every night, and that debunks the ball better than anything, because the ball cannot have converging and diverging stars. It has to be one field, and we're turning, so the stars can't separate apart out at the past when it gets past the celestial equator. If there's a known star in the north and a known star in the south, and they deviate apart from each other, it cannot be a ball, because the ball needs it to be static stars that
Where
are
do they
equidistant from
deviate
each other,
though?
do not change.
Where do they deviate?
Well, you can see it. You can see it when you see the two spiraling, the southern stars and the northern stars. They're going 360 degrees opposite each other, but they run parallel
Well,
through the celestial
I
equator,
don't know that
and then they
I
go
don't
off
know
and
that I know
separate.
that. Where
Well,
do
I'll
I
put
see that
some.
happening?
I put the pictures there. You can see that in any when you see the time elapse photography of the north and the south. You see it every time.
Yeah,
They're
you
going
that's
in
a
opposite directions,
that's a composite
counterclockwise
though.
to
That's not
clockwise.
a okay, but
No, those are real images. Just one image that's taken every I don't know how many pictures they take, but over a 24-hour period, it's just exactly what you see. It's not a composite. It's no graphics to it. People have tons of those all over the place. You can see both star fields, and the stars go counterclockwise as opposed to clockwise, literally. Not just about perspective, not just about where you're standing on the ball or on the AE map. It's all actually happening, just
okay,
like an
I
electromagnetic
need to
field.
be able to get in, Dave. I need to be able to get in. This
Okay, I thought you were
this
asking
like
for
the
explanations.
well, I am, but I like this idea of the okay, this idea of like the stars not going straight, I don't know that I see that. I'm not seeing that what you are talking about. Like the stars rotate straight over the sky unless it's pivoting around a pole. But you're saying
Right.
that you watch the stars actually deviate, and that's what I'm not seeing. Like, is that something that I'm missing, or?
Well, it's something none of us really thought about until you actually just look at what's actually happening. And I'll put these images in the wide chat right now. Now, these aren't composites or graphics or anything. This is what actually happens.
Okay,
Right? This
yeah,
is
there's
just
just straight
one
lines, no
straight lines through the
deviation,
center. It
and
pinches.
then
It pinches in the center like an electromagnetic field, and then it
yeah,
spreads out. You can see them going
yeah.
opposite directions right
But
there.
so I'm looking at it, and I'm seeing straight lines unless around a pole. So the first one and the last one, the top right corner one, that only looks that way because it's composite. If you were actually there, it would just be straight lines over your head. It would only be straight
Well, if
lines
you were
over your head.
actually
I'm
there, yeah,
trying to.
because you don't see in time elapse. But when you do a time elapse and it's one frame, it's not composite. It's not any kind of manipulation. It's what actually happens. These aren't
Yeah, no,
composites
no, I
or
agree.
graphics.
No. I mean, to a degree, they're composite, but I I'm agreeing that they're real stars. What I'm trying to say though is that like the idea that the stars are not are that they are deviating.
Yep.
I think the only deviation that I personally agreed to is directly over the pole.
Well, yeah, but
But
all of them go around. It's not like just the ones towards the center go around the pole. They all go around the pole. It just widens. The two circles separate.
okay, well, I'm gonna have to wrap my head around it a little more then.
I
We're
have a
like
question.
halfway through this video. Oh yeah, go ahead. Sorry.
I'm wondering, like, okay, with that composite, you seem like you could see each side. Well, it seems like you'd be able to see all the stars. Can we see like most of the stars from like the equator?
Even both, you know, it's hard to get both centers of the two star fields because you have to have a really wide angle lens to do that. But if you want to just have like a true to form picture that you don't try, because a lot of the ballers will say, oh, it's a wide angle lens just making them look like they do that. Bullshit. They actually do that. You don't need a wide angle lens to see that they're circling around the poles. That's obvious. And you can get a wide enough shot at the equator, like that third one I put in there. There's no wide angle lens trying to make that look like anything. And it's showing both sides deviating from each other, but they do run straight up through the center and it pinches like an electromagnetic field at the center. And they run straight through parallel and then they circle out 360 degrees and then sync up and run straight through again.
Mm-hmm. I did look
Anyway,
up
this is interesting. The way he
sunsets
explains the toroidal field stuff.
north of east and
Go ahead.
sometimes happens north of west. So it changes like direction throughout the year in which way it sets.
The sun?
Mm-hmm.
Yeah,
Sometimes
it
it's
goes south of west in the winter and it goes
yeah,
north of west in the summer.
yeah,
That
yeah.
explains why we have winter and summer. I mean, the sun has to go further away for it to be winter here. That's what's happening. It circles the south instead of the north.
Don't when you set like a magnet and like the magnetic shreds, like it forms that two thing.
When you do what?
You know, like the dual pole model has like the two circles. If you set a magnet,
Yep.
you know, like the magnetic shreds
Like a
and you
bar magnet.
feel,
Yeah.
and you set it like in the shreds,
Like he was showing
doesn't.
in the beginning with the iron filings.
Yeah. Okay. All right. That's all. I was just curious.
I don't know. This is
Sorry,
there's
the
a lot to take in if it is this way. I agree.
does it.
Go
The
ahead
moon
if you
does
want
it twice or 12 times a year. The sun does it once a year. Mercury does it 3 times a year. Um, um,
And it
Venus
circles,
does it
by the way,
twice.
yeah, I know you're not leaving it out, but yeah, so about 180 days circling around that inside of that toroidal field, right? On the inner edges as it circles around and around and around. And then finally it's discharging enough that it has to go back to the south to charge back up, right?
So it would be like this. So if this was December 21st, right?
Mm-hmm.
This would be going around like this. One day, December 22nd, December 23rd. Oh, I'm sorry, December 23rd. Then it's going around here. December 24th,
And it gets
December
wider.
25th, December 26th, December 27th. It's I mean
Yeah.
I'm over exaggerating, but
Yeah.
it falls down and climbs up, and as it does, it literally goes out wider, goes out wider, goes out wider. Every day it goes around, it goes out a little bit wider, and then one day, March 30, March 21st, it'll come out to the apex of this whole toroidal field, and it'll cross over.
And that's where you get the figure eight sun path. If you took the
Yep.
picture every day, you get that toroidal field or that
But this
dropping
is the movement.
over and the donut and inside and around the donuts is where that shape comes from. Interesting.
Yep, and I'm over exaggerating it just so you
Yeah.
can see, but this is the toroidal field that you get, and people are going to say that it's. Or I've heard people say in the south it's so much bigger, in the north it's so much smaller, or opposite of that, or that it's not, and all this kind of stuff. It is. It literally is bigger as far as the field
Right.
in the south is bigger, but it's only because the sun is charged in the north. So the north, when it's charged, it's going to hold tighter to the central of the toroidal field, as opposed to even if it's at the exact same position as far as fully charged or fully discharged. This discharge is going to be, the field is going to be bigger as far as it's not going to hold on as much.
Right, because
You
it
see what
doesn't
I
have
mean?
any charge, yeah, and then it has to go back towards the center to get charged back up again until it gets enough oomph to go back up to the north again, and then it starts to discharge as it circles around and then loops back
There
around.
you go. Way to go ahead and use the stars, because I went ahead and learned the only way we can plot stars is on a grid like this. You can see that you actually have a grid for your position as far as where you are from the prime meridian and where you are from the celestial equator, and how you actually break it up and do it out. And what you're going to see is on the map, you're going to see the grid as far as the longitude from the prime meridian are going to be separated out in 15 degrees. 15
Mm-hmm.
degrees from the center, go out 180 degrees each way, and that would be your north. I'm sorry, that would be your east and west. As far as if it's negative, it's west. If it's positive, it's east. The same thing you would get is if you go through to your latitude, as far as the declination from the center, or from the celestial equator, or from the North Pole, or the South Pole, as far as 15 degrees. So you go 15, 30, 45, is that
60.
right? No. 60, 75, and 90. So then you go through, and you can see that actually gives you your grid when you put both of these together. Oh, I'm sorry. You have your north and your south. So you put both these together, and that gives you your north, south, east, west, so that you can have your four corners of the grid, not of the four corners of the earth. I'm not trying to say that. I'm just saying that you have your four corners that you can map out your grid, so that when you do your grid, you can actually have a place to map it out. When I did that, I came up with this map, and I remember you, New Perspective, telling me that I've seen this map, and you're like, you started sending me images of this, and I was like, what the hell, man? I spent all this time doing all this.
Yeah, well, that was what I sent you. Yeah, it looks just like the two pole AE transform of the graticule. And you didn't even know what the graticule was, but you came up with this on your own, which is highly impressive, I must say.
Well, it was very nerve-wracking for me. I mean, yes, it's great. I'm happy it was starting to look like something that we were seeing somewhere else on, let's say, the internet, or that other people were using. and that's great. But that meant something was wrong. That's
Right?
if
Because
that's what
why
was
hasn't
happening.
everybody else figured it out by now? Right.
Well, why aren't they using it? Why aren't people jumping
Right.
up and down and trying to explain how this would work with everything as far as how it goes? And I've never seen anybody put this onto this as far as I'm sorry, I've seen this, but I'm not seeing people use this as actually plotting latitude and longitude with the stars. As soon as I started doing this, I learned that I had to go through the most outrageous, unimaginable things to be able to plot and use the stars. So I started looking at, maritime almanacs or star charts, star times, GPS, to where I could actually sit there and plot the stars with the sextant, uh, clock, and all that kind of stuff, and figure out my latitude and longitude. I had to go through all kinds of things as far as figuring out the position of the noon for each observed angle that I was going to, or each position I was trying to plot. You had to go through and literally find out where your stars were going to be, as far as the angles, the declinations, the azimuths, things like this. Figure it all out with a scientific calculator so that you would be able to figure out the amplitudes between everything, because it's all calculus. And what I came to figure out was that wasn't what was happening. This is the U.S. Observatory Astronomical Application Department from 2025. The same thing that you're going to get from any nautical almanac for using the stars with your sextant to chart or plot your position. So you can see that you have to start, because you're reading it from here backwards, because this is going to be a mirror image of what you're looking at, since you have to look at what's coming and not what was. Anyway, so you can see that you start Polaris 33 degrees. So if this is 360, this is Polaris is sitting at 327 degrees. And you can see that's 33 degrees off the vernal equinox. And the vernal equinox is where we start time as far as when, on March 21st, when the sun crosses over the vernal equinox, is when they start the precession of the equinox, as far as start the precession of the constellations that we have for, Virgo, Cancer, whatever, however you want to call it, as far as the month that the sun's within inside of its thing. And the
And
problem
just to be
is
clear,
that
that line right there on the right, that's the prime meridian that you're talking about.
yes. So if you're looking at my map or a regular map, it would be the prime meridian is on the Greenwich right here.
Mm-hmm.
And you can see that would be here. And the problem with that is the sun comes up exactly, well, I shouldn't say exactly, it's 60 degrees off of wherever you're at. And you can see that this would be 60 degrees off of where the vernal equinox is. But they had to move it 33 degrees because they moved the prime meridian. That's why they have to do this, because in order for these stars to line up, you would have to move this sun, or the sun within inside of this movement of these stars, 33 degrees, so that you would line up with Greenwich, and have it to where the sun was still sitting over Orion's belt, or within Orion's belt on March 21st. Otherwise, it doesn't work out. Your stars aren't put in there. And I can show you that.
Well, that was a taste, and I could give you another one. And well, that was a taste, and I could give you another one that follows up on that if you want.
I would like an introduction first, like before asking them questions. Like, is there like a short, you could share with me, like just like going over, like just a summary?
That was one of them. I sent
This
all of them
is
to
the
you that are kind of
introduction.
some of them. Yeah, that was the start of it.
Oh, you're
Yeah.
the first person he talked. He never made a
Huh?
video.
Well, we're making the videos. No, there's more. There's a lot more.
Oh, that's cool.
You want to see more?
So you're working with him to put it out there.
Yeah, because he's explaining it to me, and we're screen recording our conversations rather than having it be, him just doing it on his own.
Yeah.
That's cool.
But here's another one if you want to play it.
But just before, I mean, I don't know. I can't see my Discord while it's up. I've only using one monitor for this. So
I put
did
it in the
anybody have
chat.
anybody who's here, did you have any questions of that second half of the video? Okay.
I
All
find
right.
it pretty
Yeah, if
interesting.
you're I'm sorry?
I said I find it pretty interesting. Like, I don't know. It's
It's
crazy.
like a
Play the
different way of
start of it.
thinking. So like I'm having to like rewrap my head a little bit, kind of like re-question things I'm not used to having to deal with. Okay, so let me pop this up.
This is an answer to the
Oh,
24-hour sun.
okay,
I mean, that's the thing.
this one's much longer. Is this
Have you shared these with Witsit?
Huh?
Have you shared them with Witsit?
I did. I sent him to him, but he hasn't been around, so I haven't. He never replies to my DMs, so I
Yeah, he didn't
I
reply
don't
to
know if he's
anybody.
gotten them around.
But
He'll be all over this though. He's already saying the sky's electromagnetic.
exactly. So I've seen it before. They put like the AE map and then Antarctica just at the bottom, but then maybe like an ice
Yeah,
ring.
that's how he started. He started
I
with the sun
think
circling. He's about to talk about that.
the concave people, that documentary with Bilu and whatnot, I think they even used a map like this. They were saying that Antarctica was its own land, like off in the distance.
Definitely. I think that's been the trick the whole time. They got all the flat earthers thinking Antarctica is a 360-degree circle around us. And I've been talking to E1 ever since I figured out that we're not on a spinning ball. And he's been talking about the southern stars, and we were opening debates by talking about the southern stars with ballers saying they can't converge and diverge. And the sun circling in the south, he didn't figure out till later. So he's about to talk about that in the beginning. He thought it was circling like the AE map. Then he realized, and he started plotting the position of the sun. And he sees it's going way south of west when it sets in the winter, which doesn't work with a circling sun. That debunks the AE map right there. If it goes north of west in the summer and south of west that's two different directions. It can't be going in one circle if it goes south and west. I mean south and north of west
I mean,
half
I
the
got
year.
ideas, but yeah, I see what you mean though.
But yeah, just think about like how much land that would be if we thought Antarctica. If they're trying to pass off that little island continent of Antarctica, and it's actually surrounding us, think of how much land that would be. I mean that seems like that would be very easily provable if that were the case. Like have someone dead reckon west or dead reckon east or whatever it takes and end up in Antarctica. So
Well, I don't know, man. I think if the polls, if that second poll was so secure and so obvious and so real and true, I think that we would have way more convincing evidence, preponderantly, or whatever that word would be. Like way too much. Like I don't know.
there are stars circling that
I
pole,
see what you
just like
mean.
there's stars circling the north.
I see what you mean. I just think that we would have more footage if it was. They would be wanting to show it off like a lot. They would go out of their way to show it off like often if it were an actual persistent poll. I'm thinking maybe it's like a temporary poll,
Flat
like an
earthers.
optical poll. What?
You mean like to show flat earthers? Because I think part of it, they might have had that 10-year plan, like we were talking about. Like they
Like
wanted
the shill
flat
flat
earthers to
earthers?
put. So I'm saying like you know how we talked about like 10-year plan, like they might have had it all like TFE in
Yeah.
the bag, like.
Oh, I'm certain. I'm certain of the 10-year plan.
Well,
Yes.
for those 10 years, they were glad to have flat earthers believe that Antarctica surrounded us, because they were gonna, or think that it's an AE map or the sun only circles in one direction, because that's what they were gonna hinge all of their debunking on with this 24-hour sun. Even though this whole time we could have seen it go the other direction in the winter. But it's like they didn't want to push that, like, oh, look, Antarctica's its own continent. That might be TFE, 2.0, as they show Antarctica for sure as its own continent. And then people that are stuck on the AE map then will have to really bite it. But regardless, the
Okay,
24-hour sun
I know this
doesn't look
sounds
bad on its own.
just hear this out. Like in all of my research, in not just like flat Earth, but like literally everything, I feel that they would want me to mock and disbelieve the thing that is true. Like they would show me that, like it's part of the karma. They would show you the true real thing, and then they would disguise it mentally. Like they would give you propaganda to disguise the real thing. So that way they would they never have to worry that you're gonna accept the real thing as the true thing, because they've got everyone to mock it. So
Right, which is why I've thought about like the idea of like this TFE thing, even though it wasn't necessary to know there's a 24-hour sun. It kind of pushes the hand. Like if it wasn't like say E1's right? Well, he didn't do it because of TFE, but some other flat earther might consider two pole models and figure out what he figured out or whatever. And it's like they push that hand. They didn't need to do that. If the AE map is wrong and Antarctica doesn't surround us, then why wouldn't they just be happy enough for flat earthers to sit with the wrong model and be wrong this whole time forever? But now they've pushed it so that if you know the Earth's flat and you know there's two poles and this is actually how it works, then people are going to figure out how it actually works. So they're like pushing us to the truth, maybe intentionally, so they can
I think they're
eventually tell
fine
us
with
the quote unquote
I
truth
don't know.
about flat Earth, and then do the outer ponders as the aliens, like I've been saying this whole time. Who knows? But they didn't need to do TFE. That if we had the wrong model, they didn't need to do TFE to debunk anything because we already had the wrong model. Why would they care if we had the wrong model?
I think you make a good point, Dave. I think just the stuff itself is pretty compelling. Like that map looks pretty realistic, and what I studied the magnetic fields because I was trying to understand the Coriolis effect based on the magnetic fields, and basically like the magnetic field, like a magnetic field like that could produce the same like Coriolis effect, where in one hemisphere you have them rotating clockwise, another one rotate counterclockwise.
Yep.
The weather and the
The
water
drift.
magnetic field
The
affects like the
drift. Yeah, the 15-degree drift is going to
and
be a
so
sidereal from the sidereal rotations.
whenever I was looking into that, I was seeing like the toroidal field, like where you have like a north pole and a south pole of like the magnetic field lines. And that like kind of explained the Coriolis effect, like where magnetism makes the water and weather move this way, and then why wouldn't the stars move that way? Like so that kind of opened me up. It's just basically it's the same thing. Like put an AE map with the North Pole right there. All you're doing to change it is making Antarctica a continent and having a south magnetic pole. Because right now, where is our
Yep.
south pole? Is it everywhere? Because we have a north pole, but they say the south, like they're just zooming in on the magnetic pole where it's like, okay, we have a north pole and everywhere is south, but like normally with a magnet, you have like a north and south pole, like actual spot, right?
You have to. You don't have
So, like,
there is no singular pole magnet. Yeah.
I think they think it's like underneath the earth is the south pole, like or something. Like the south pole, like point, like that would be
Yeah,
under.
well, whatever it is, like, yeah, you have to have two poles for the magnetic field lines to even exist. You can't have a ring magnet around a center magnet for it to work that way.
I think
And
that
it
what
wouldn't make the
happened,
latitude lines anyway. Latitude
the,
lines wouldn't even work that way.
there's got to be a south pole somewhere. So, like to the
the
magnet itself.
the outer rim would be the South Pole. It's not. It's not a ferromagnet. It's an electromagnet. The field is. It's created by the flow of energy. If the energy is flowing towards the outer ring, then that would be your south. It would be aligning your pointer center to south.
But a ring magnet around a regular, like there's no array of
it's
magnets
not a
that work
ring
that way.
magnet.
We can configure it.
It's an electromagnet.
Well,
You
where's
can
the south?
align the field however the shape of your what? Who's talking?
Can you make an magnet work that way? I've never seen that.
Yeah. Yeah, I mean you can shape an electromagnet however you want. The thing is that I don't know how to evidence this to you, but it's not a
Well, if
sitting,
it's an
it's not like
electromagnet, we might.
it's not just a regular it's not a what do you call it? A rare earth magnet. It's not a rare earth magnet. Okay, those are entirely separate.
Right.
We're standing on an electromagnet. It is due to the flow of electricity that is creating the direction of north. And that's
Yeah, but I
I'll
don't
just
think
say
we
that.
get.
So
I think what the compass is reading is a magnetic field, not an electromagnetic field, because it would be a different effect.
uh
Okay,
I
so
don't
the
know. I
ferromagnet.
disagree.
I'm gonna look this up because I don't know. They might both have like a south point though, like a south
No, no,
point.
no, no. It's yeah. No, of course they have a south point. Because if at
This
any point you
south.
have a needle pointing one direction, then the opposite is south. That's not what we're talking about. We're literally just talking about what is creating the magnetic field, whether it's a rare earth magnet, which is caused. Okay, look, you have to understand when you're programming. I don't know if it's a lodestone or if these are the same things. When you're programming a magnet, you're creating a magnet. Okay, what you do is you get it really, really hot. Okay, you get past the Curie temperature, and then as it's cooling, you set up a magnetic field around that piece of metal so that it freezes. It essentially captures that magnetic field that it's solidifying into. So it orients itself to the surrounding field. Right. That's how you program and create a magnet. Now, the Earth is not it's not one of those magnets. It is literally an active electro field. It's no different than the wiring in your house. The wiring in your house can create a magnetic field if you set it up that way. It's just due to the flow of electricity.
I put a picture: magnetic field versus electric field, and or magnetic field versus electric field, and like what each would look like. I guess.
Yeah, they propagate the same. It just depends on how how you're creating it.
So we're focused. Okay, so I think that what the FE map, it's like, okay, so see that little red plus on the right on the electric field? Like we've really zoomed in there, right? But where's the other side? Somewhere. Like we zoomed into that tiny spot. I'll take a picture. This is what the FEA map is like right here. But maybe there's a South Pole somewhere.
Yeah, they're the same fields. Like one is those 2 points could literally just be wires, and the north and south on the left could just be one piece of metal or one magnet. You see what I mean? Like the wires can propagate it identically to the magnet. The difference is one is a static magnet and the other is it's dynamic because it you can obviously change the shape of the wire, you can move it around or whatever, and it's going to change equally the type of field that's emanating off of it.
Okay, well, like this is what I think is the most compelling part about what E's saying, right? What we have on the left here, what I just posted, is an electromagnetic field sitting on top of a magnetic field. And you can see that if this is what actually the Earth works like, right, then we have the magnetic field underneath, and that's where the latitude lines come from, just like they have on Earth. And then we have the electromagnetic field that the stars run on above us, and that's what we use for latitude lines. So if this is what it actually looks like, if you have those two combinations, is it just a coincidence that our latitude and longitude lines, as well as the coordinates with the four corners and everything they use practically to start to figure out the distances between the continents and plot all the stars with the four cardinal directions, and they deploy satellites using that electromagnetic field to have them circle around us and using that for the ISS, whatever that is, and all the stuff they actually practically use looks exactly like what I put on the right. And if that is an electromagnetic field over a magnetic field, and it's actually the way the continents are underneath with the latitude and longitude practically used, and this is what they actually use, then is it just a coincidence that looks exactly like an electromagnetic field sitting on top of a magnetic field? That's compelling. That seems like this has got to, I mean, this is how this is why it looks like this. This means that they didn't make the graticule to trick us into thinking we're on a ball. The graticule looks like this because it has to look like this, because that's the way the fields are. And that's how they use them for direction, for deploying shit in the air, for navigation. And then you can see that the way the lines curve, that's how they conflated the curvature of the Earth. So when things are having a magnetic declination or deviation, and they're going over that curved line, people are thinking they're on a ball because the line curves. They're doing a great circle or whatever it is that matches up with these field lines. They conflated all of that curvature in the field lines with being on a ball. It makes perfect sense.
Big if true. Big if true.
Yeah.
I want to go into this next video. I'm only a little concerned. I want to make sure anybody who's really interested is going to be able to watch the whole thing, I guess.
Nah, whatever. You don't have to watch the whole thing.
Or
Just play some of it.
unless there are parts you want me to see, I'm happy to play it.
I have no idea. You could just play it and see what happens.
Or
play some of it.
unless there are parts you want me to see, I'm happy to play it.
I have no idea. You could just play it and see what happens. If anyone objects or has to ask questions, you can stop it.
Cool.
Under the impression, what many people are under the impression, even I would even say ballers are under the impression that there is one circuit, one movement around, and it's summer, the equinox, winter, another equinox, and it just keeps going back through here. That's why you'd have the Tropic of Capricorn and Tropic of Cancer, or I think I'm backwards on that, but you know what I'm saying. And
Right.
then if you just take away the thought of thinking I'm on a ball or I'm on a one pole system to where we only see one set of stars in the sky, which that isn't true. You can go outside and we can show it. You can literally see it yourself by doing star trails, by looking at any type of solarium, anything like that. But as soon as you realize that there would have to be another pole, you would have to have another magnetic field, and that magnetic field would look something like this. I know you're not seeing the map really great yet to magnetic field like this.
Yeah.
As far as you can tell that it's there is the star rotation around the southern part because of, you can go down here and look at the Southern Cross. It's not on the actual apex or the zenith of the pole, but you can see the rotation. You can see how you can actually use it that way. And the north had the exact rotation. You have a 24-hour sun in the north during the summer. Why wouldn't you have a 24-hour sun in the bottom is what I was starting to understand. You would have to. If you had this at the top, you would have it at the bottom. I didn't connect them yet together. As far as understanding how they worked, I just understood it had to move down to the exact 23 latitude as the north, 23.4 degrees. It had to go to the exact same 23.4 degrees because that's what it does. I mean, that's what it actually does. So you would have it swinging around just like a figure eight. Didn't have this yet. I didn't have the idea. So I knew that it looked somewhat like this. As far as I was under this understanding that it had to look somewhat like this because of the megalithic structures. I thought it was a pyramid turned into a straight line, and then that's how it was done because they were measuring the Earth to get the circumference of everything to find out how big it was, how far it was from here to here, and you can do that with trigonometry. As far as everything from the center of the North Pole to Egypt, you would know how far it was, and then exactly how far the sun circled out. You would be able to figure out all of this by mathematics, just by trigonometry. And what I didn't understand was the whole movement and that the two poles. So as soon as I did I knew that I was wrong on this, but it still made more sense than anything. And I decided I had to go learn how to do the stars. As far as I needed to know exactly, I guess it would be the position of like this would be my map with the planets as far as Mercury goes around in 88 days, Venus goes around in 264 days to come right back around to the exact vernal equinox or 0 degree latitude, whatever you want to call it. But they all go through their certain amount of things, and I was starting to draw everything out in a 2-pole system. But I knew that if I could do this, I could literally do it by mathematics. But whenever you're using the stars, as far as you're plotting from the stars and everything, you're using a celestial sphere or disk to do all your charts by. So you can only, if you're in the northern hemisphere, you can only use the northern stars to do this plotting, and that means that from this disk, that you're literally looking to a central point north. So you can only plot up from this center point. In order to plot down here or to move down to plot in this part, you have to be in the southern hemisphere, and you'd have to plot off the southern stars. You cannot plot in the southern stars and plot this way.
Yep.
You see what I mean?
Yep.
Okay, so that means that you have to, whenever you go out and you start to, I didn't bring a pencil. Oh, I got it. Okay. So when you're going out and you're looking at this, it's not just a cross. It's a cross with a circle and a circle, because now you've got the prime meridian, the celestial equator. The prime meridian in the north, you go from the prime meridian clockwise 180 degrees around to get to the international date time zone. You go 180 degrees counterclockwise on the south to get to the international date line. You go 180 degrees east to get to the same thing. So now you can see northeast, southeast. I'm sorry, southwest, southeast, northwest, northeast. How you have your 4 cardinal points and how you can have north, south, east, and west on a flat plane. As far as how it works, how you have to chart from it, or how you have to navigate by using the stars with inside of here. Every time you flip over, you move from one side to the other.
Yep. That's awesome. And that doesn't work on a ball either, that's for sure.
Right.
I like the
That is
crickets.
for sure. So, if you want to take that and go to what I started looking at, so I started making the map look, as far as when I started drawing the map, when I would do literal headings, not so much just this is what I think it looks like and this is what I feel it looks like as before. Now I had actual GPS coordinates to check. I could actually go, each one of these lines was 15 degrees off, and you can see that it's set off of, it's not on Egypt, it's on Greenwich. So each one of these 15 degrees gives you 180 degrees out to here. You can literally map out your north, south, east, west, or your north and negative declinations as far as how it would be when you're doing your plotting. And you can see that it worked. As far as it literally worked. I can go and do any type of GPS coordinates, plot them down. Everything works out as far as you can't tell the difference, except for when you start bringing in the sun and the moon. As far as the light, the amount of light that would be in New Zealand has to be at the minimum at their so it'd be their summer. So June 21st. New Zealand has to have 3 hours and 20 something minutes, or maybe it's 15 minutes. It has to have that much of actual direct sunlight, and it wasn't getting that. Down here, it wasn't even getting an hour or 2 hours of sunlight. But as soon as I realized that there was something still wrong, I knew that this had to be right, but something was wrong. I started realizing that there was some connection between everything that I was seeing and trying to figure out here and all of the ancient civilizations. these ancient civilizations, Egypt, any of the Taoism or, Tibetans, monks, even the Knights Templar and any of Rome or the Vikings or any of these people were not using calculus and charts and sextants to navigate, and they were navigating very well better than anybody else that came after them for hundreds and hundreds of years. So when I started to really realize that they were using those astrolabes, and an astrolabe is pretty much a piece of metal that has not this many stars, but it'll have a few stars on it, a few points on it, and then it's got an overlay of metal that shows you a point to a certain point and a point to another. So all it's going to do is give you an average from a certain latitude for these certain stars, 1, 2, or 3 stars. And what you would do is you would hold that astrolabe up and you would get the angle of the star, and as if it was in that area of that star, you knew that that was your angle of what you were going to be shooting for, as far as you were in that latitude of what it would be, and you could figure out your amplitude for you to be able to triangulate where you were on the grid, on the latitude and longitude. You didn't have to have charts and all this kind of stuff. And when I realized that was the case, and that they were doing the same thing that we're doing with modern day triangulation with navigation charts, I realized that there was something that I could make to where I could pretty much give you a map of it, and you could have the stars overlaid. Is that sitting the right way? Sit right there, this way. East is up. South, north, west. And you can see that if you look at the way that this would be both the star disks above you, circling above the plane of the map that I've made. So you've got Antarctica, South America, North Pole, and everything that just goes around it. And in order to use one of these, you can only use one at a time, because you're only going to be able to triangulate from one central location. You can't use both at the same time. You can't actually see both at the same time. You can't actually, these stars past the celestial equator are the southern stars, but you have to have it to where you can triangulate with it when you're in the north. And how you can see how that would work is you can see that if you put the overlay that you would use for your observer's position, you would be able to look at, they converge, the actual lines that you're looking at converge looking north, but in the south they
Guys, I'll be
diverge.
heading out now.
So everything.
Hey, Dr. Active, thanks for hanging out. Catch you next time.
Sure.
Anybody got any questions so far?
Now he, just to let you know, he made these, like he used the Weems and Plath, the ones you can order that are like the navigator's like go-to company for star information. And then he made his own, he printed these out on translucent paper and made his own custom star map that was scaled down and giving you the true position, so you could go and check where the GPs of the sun are, or the stars are in the south. And I could call up a friend in Australia and be like, okay, if he's worried about these stars circling in both directions the way he's got it, then you should see these stars above you right now, because I'm seeing these other stars that are fitting with the cogs of the wheel the way he's got it set up. And you could falsify his model that way. Anyway, he's explaining it right now.
Okay.
That's past this line right here is literally offset of what it actually is, so that you can get your measurement or your reading, so you can mark everything down.
Now explain.
So this is a Weems Plath, as far as it just gives you from Aries, which is supposedly where the vernal equinox is from Aries. It starts off at a 0 degree declination or 0 degrees, and that would be Greenwich. And it just maps out the stars within the northern hemisphere as its declination or its local hour angle for Greenwich, and then its sidereal. This is actually a sign would be at this exact location. Then
And
you take
those are the navigation stars, the 126 stars that we use for navigating. Not all the stars, obviously, but just to make that
right,
clear.
just the
Yeah.
and there's only like 60, within here, or 50 something here, and then there's 50 something here, or 60 something here. It's not like it's only within each side of this disc is what you're actually using.
Yeah, and that's the celestial
Per,
equator, and everything outside that celestial equator goes. Just to make sure people realize, those stars don't go 360 degrees around the celestial equator on either the north or the south, but they're included in the north or south disks so that when you're looking south or looking north, those stars are going to be there. So they're only useful when you're looking north or looking south on the outside of that circle, right?
correct.
Yeah.
Correct. Exactly. Yes. I mean, you are going to have if it's a true magnetic field and it's powerful enough, which it is powerful enough to hold the sun within the confines of the top one during the summer, the south one during, or the north one during the summer, south one during the winter, then most likely in real life, what you're going to find is you're going to get an opposing field that's going to look like if the stars are moving like this, at the edge, it's going to look flat, but it's going to look curved opposite. And it's going to be these stars, but it's not going to be the actual field. It's just going to be a residual field that would be the opposite of this.
So it's interesting because that you're saying there that there is some sort of parabolic reflection going on because of the magnetic field on the outside of the field that we are within, but not for the southern stars the way people think about it as a parabolic reflection for just the southern stars altogether.
I don't know yet because I haven't been there. As far as
Yeah.
in order for me to get to that area, look at the map here. This is as close as I can get to because it's not exactly perfect or anything. But if I put my stars or put the stars on top of my map, and you see where the celestial equator is, right out here, you can. Oh, I'm sorry, that's not even close to true. It's out here. You're going to have to, in order to get to the spots where that's going to happen, you're going to have to go to either here, which is 180 or 165 degrees west, one latitude, or 180 to 165 degrees. What would it be? I guess it would still be one, but you're going to need to go up to like 10 degrees and then start going south of north to get to those places where the stars will actually bend in that fashion.
Right. And just to
thousands.
clarify again, you're not talking parabolic reflection off a dome or a firmament. You're talking about magnetic fields have that doubling outside of them. Typically, is why you're assuming
Right.
that might be the
You
case.
just it's not that they always do, but if the field's powerful enough, you're going to have the residual that's going to be the opposite, or whatever the inverse of that magnetic field is.
Right. That's interesting. That's the reason that a lot of flat earthers that think that it's an AE layout or whatever use that same type of philosophy, but it's more about like a parabolic reflection from either the dome,
Right.
the firmament, or your personal dome of vision, that type of thing.
But see, you won't have that here. There's the other one. You won't have that here, and that's the point.
Yeah.
That's why the prime meridian's here. That's why the celestial equator is here. As soon as those stars get from, I mean, I know that you can't use this together, but as soon as those stars get from right here, you have dispersion or you have anomalies. And it's
Yeah.
not so much that you have anomalies everywhere, but wherever this point is where the celestial equator would be starting to deviate away from each other. I know you're still going to see that and it's still going to move, but it doesn't move in a full circle like this. The
Yeah.
actual stars move in their format like this. So they move in an oblong or oblate spheroid, like some
Right.
people like to say. But the stars actually move in this, but you can't map it except for a full 360, a true 360-degree circle, so that the timing of it for your angle of when you start putting your overlays, so that you can have an actual metered time, an actual correct time.
Yeah. So
So,
explain that. Explain like you were telling me about that with the fact that you made these overlays and you were kind of surprised that these perfect circles would work with your layout because the corrections that you were doing with the amplitudes and all the calculations and everything you were showing me to begin with, you found out that's not even necessary because this corrects for it. And we don't see that the perfect circles in the skies for the stars. And I was thinking, oh, it must be a visual thing. They just look like they're not perfect circles. But you're saying the magnetic field isn't actually perfect circles, yet because of the way it works, they still make a 360-degree turn back to its original position somehow. And that's what this is showing. And it takes care of having to do the calculations for the amplitude, which is the reason you had to do it to begin with, was because they weren't perfect circles, right? Or maybe you could put it in better words.
well, it wasn't just that it was perfect circles, is that they weren't showing, or you aren't aware that this is what you're doing. You don't know. People don't understand that what they're doing is they're going out and looking at a point, a star, whatever, however you want to say it. We'll just say in the center of this circle right here, you're going out and you're looking up at that circle. And it's not that you're measuring the angle of this circle. What you're doing is you're opening one eye and closing another. And that what's going to happen when you do that is this finger is going to go doot, doot,
Yep.
doot. And what you're doing is you're figuring out not the distance, the actual. So if it's 70 degrees, if I'm looking this way and I'm looking out at that star and it's 70 degrees to this one, and I open my eye and close the open eye and open the closed eye, my finger jumps over here, this is going to be at 68 degrees. And that difference is the difference. So if it was 70 degrees to 68 degrees, that's a 2 minute or a 2 mile offset amplitude. So then I would literally, whenever I go to shoot my actual stars, I've got all my averages done out. You would shoot your star up to 70, and then you would mark up off of it 2 miles. And that somewhere along that line you are going to be, and all it is that you are on one of these lines. These are 15 each line is 15 degrees up to 90. So you've got 0, 15, 30, 45, 60, 60, 75, and 90. Right. So when you're doing what we're talking about here with the amplitude or even looking at the stars, you're literally saying, by doing all the other things, that your average, you think you're on one of these lines somewhere. And then when you use this graph on it, that difference, because this is going to say, you're going to say, oh, I'm on the 30th parallel, or 30th latitude. You're going to grab the 30th overlay, as far as the 30th latitude overlay, that's what this would be, and you would overlay it on here, and it's going to give you exactly what it should be when you look at that star. And then you're going to go out and you're going to look at that star, and whatever the difference is going to give you that thing. And as far as it's going to give you that amplitude, and you're going to figure out that amplitude as far as on here. And when you do, if you would have used this, right? If you would have looked at that star and it said 70, and you went out there and you shot the star with the compass and it said 70, you would have been right on this line. Because this is the 30th line, that's the 30th line. But since you go out and you look at it and it says 68, and your compass says 70, you know that you're 2 miles off of wherever that center point is. And you just have to, whichever direction you're shooting your star, you draw your line, you move it up to 2 miles or whatever the distance is. You draw your line 90 degrees off of what you shoot it, and you know you're somewhere along that line.
Yeah, and just so so it's clear, it doesn't really have anything to do with closing one eye and opening another eye, but it works in the same fashion that you would figure out the difference between that and your regular visual measurement of something with your one eye closed and your second eye, and then you figure out the difference. But this amplitude is something different. This is correcting for the non or the circles not being perfect in the same
It's
way.
like this. It's like if I knew that it's doing trigonometry is what it
Yeah.
is. So if you close one eye and open another, you know that the difference as far as what it is, it's not going to look like this, but this is what it is. You know the difference in your finger jump that much. So when you're looking at it, that would be one eye, that would be the other eye as far as when your finger is. The same way would it be is if you're looking at a set of stars and the graph that you just overlaid it literally showed you 35. It would be like you closing one eye and opening another would be like moving this and going 37,
Right, but
35,
it doesn't really
37.
have anything literally to do with closing one eye and opening another eye. It's just
No,
similar. It's a
no.
similar type of correction that you have to do for these star charts to work. What the amplitude is correcting almost for the stars not making perfect circles is kind of the idea I got, right? Because now you found that the perfect circles they make it so you don't have to do that any longer.
Right here, it'll make a lot more sense like this. So, you can see how the celestial equator is on the equator here, right?
Yep.
I mean, the center of the map anyway. This is the equator as
Yep.
far as how I'm depicting the equator. This is the map with the celestial equator on top of it. And the celestial equator, when I'm spinning it, never deviates from that exact point. It's always sitting right there.
Yep.
But if I take my overlay, I'm going to have to remove the stars just so you would understand, or people can understand what I'm talking about. When you put the overlay on, you can see that if you're standing here, the stars don't go around in a circle. They go out all the way out here. From this position, they go let me come down a little bit.
Uh-huh.
They come all the way out. The same position here comes all the way out here. But as it leaves over here, it's perfect circle up here.
Yep.
And so I can show you that as I turn it. See how it still keeps it exactly, the star stays right on the, if you follow these lines, that star stays
Uh-huh.
right on the celestial equator, but you're still moving. Everything's still moving around as far as the position of the person, but it still stays on that celestial equator.
Right.
It's really strange how that, and it's still, now it's a circle up here. It's not that oblong weird shit.
Right.
Now it's a circle.
Interesting. Yeah. So you
So
weren't
it's not
even you weren't expecting that your custom translucents. Now you had to make those and get them and printed and everything. And you kind of used the Weens and Plath star charts to customize yours. And how close are they? Are they pretty much exactly the same, or are they?
well, no, same. So I had to bring mine down just percentage wise. It's not same or different. The stars are what they are, and this
Right.
isn't Weems and Platt. They can't copyright this. they
Yep.
they didn't make this.
Right.
Then
It's
nobody
just what it
can
is.
copyright that or anything
Yeah.
like that. They can't even copyright star charts like this
Yeah.
because they didn't make them. They
Yeah.
don't make any of
It's
this
just
stuff.
showing you the stars, right? It's like you can't own
It's
a
just
map of
showing
the
you
United
because
States. It's just a map of the United States.
well, no, they can copyright those types of things. Oh, sorry. They can copyright those types of things, but they can't copyright, like they can copyright that somebody can't sell an exact Weems and Plath everything like it, but
Oh, right.
they can't take this information. Is what
Right.
I'm
They
trying to
can't
say.
copyright. Yeah. Information. The truth is the
Yes.
truth. They can't sell the truth.
And I can't change the information as far as in an actual model that I would be making that would be able to be usable to where I can literally take and put the stars on the actual map. Well, I'm just going to use one of them for right now, but you couldn't do that until it actually lined up with the celestial equator, had to line up with the prime meridian, had to line up with the celestial equator on the map. So it took me a
Yeah.
little while to figure out what the discrepancy was between this one and this one as far as the size. It
So you
wasn't
scaled
much
it down.
different, but it was.
Okay, you scaled it down to fit
I
your
had to
map.
scale. I had to scale it down, and then I had to change this because now I understood what was happening here. It wasn't just me drawing a map off the stars that I was going off of. Now I had a map that I was drawing the stars off of that had to have the declination of this up at 10 degrees, or I'm sorry, up at like the 60th degree, but it had to have the declination of something of this big out here at like
Uh-huh.
10 degrees or 5 degrees. So everything had to be redrawn so that whenever I actually put the grid on top of this and not just remove the stars and went, oh yeah, it kind of works, it works. I don't know, it kind of works together. Now you can put the grid together to where now you know when those stars are at that point, that's exactly where the grid is on the, as far as the latitude and longitude. Literally mapped out minute and second of the latitude and longitude.
And you've been able to cross-check with the GPS GPs of these stars and see that and you said you've double-checked several different areas of your southern and northern land areas.
Well, see, that's a problem for me as far as so I've done this so many times at my house that I'm literally within 100 feet as far as seconds away from on my. I'm not going to give my latitude and longitude, but
Yeah.
I'm seconds away from where I should be as far as where I think I am and when I check it. Who knows if GPS is actually correct? Who knows if they have a discrepancy as far as what they have? But that's really close. Being
Right.
100 feet from what they're saying as far as what I'm getting off of this average and using my own way of doing this. I've done it with the stars too, and I got not as close with doing the stars the modern way. I can get a lot closer by using this map and doing everything that way.
Right.
But it's that I've gone here. I've gone 100 miles. I've gone up to 200 miles away and done this and was really, really close. I was the furthest away I was 400 feet. I'm sorry,
Wow.
500 feet.
Wow.
Now that I really know how to do it from the GPS location, but that shouldn't be. I know that's amazing, and it is. Don't get me wrong, but it shouldn't be amazing knowing what this is and what it shows, because that's what it has to do. It has to be able to be replicated that good to show where you're at, and everybody's got to be able to do it.
Yeah.
I should be able to give this to anybody, and they should be able to go outside and go, oh, is that where the Big Dipper's at? Okay, well, it looks to me like it's just past north, so we're gonna put it right like that. Okay, we'll put the little thing on there. Okay, it says 35. Go outside, grab your compass. Look at it there. You go, okay, well, let's see here. It says it looks to me like 45, but the thing said 41. Well, that means we're 4 degrees off. Whenever you do this, 4 degrees off.
Uh-huh.
Boom.
Right.
And going to take the world so you can see that north is up, south is down, and we're going to turn it so you can see that you can see the magnetic fields. So north is to the left, south.
So is the reason that they want Israel to be like the capital of the world, or like the main hub of the world, is because it is the center of the world? Is that kind of like the idea?
Well, he has Egypt as the center.
Well, I mean, relatively speaking,
That area. Yeah. That's the
that
being
area,
in that
yeah.
right in that center area. Yeah. Yeah.
I mean
that kind of lines up with
I
it.
know that's kind of like secondary and totally speculative and all that, but
Yeah.
I find that reason enough. I mean, like, why would they have? I've always wondered, why do they want that area? Like, what's the whole
Yeah.
point
It's not
behind
very.
that?
It's not very conducive to living. Like the sand and
I
everything. It's not.
know, I know,
Like why would
and I just
you
kept
want to
thinking, well,
be there?
maybe it is the middle,
Exactly. I thought
like
that
in
too.
that way they can keep tabs on everything. If you have the internet connected, you'd want to be in the center. Like whenever you put in the Wi-Fi in your house, you want it to be in the center of the house.
Yeah. When
For
you play chess,
propagation.
controlling the center of the board is the most important thing.
Yeah. So yeah, I mean, I'm trying to come up with
Does
my
line
my
up with that
reasoning.
philosophy for sure. I thought that
Um,
myself. Yep.
gives me
That would
gives
make
me
sense if
some
it's the center.
stuff to like think about, look up.
Yep.
Just to the
I think
right.
you're right about that.
We're going to go ahead and put on just the magnetic fields, the actual longitude lines that you can use a compass to find. That would just be
Right.
these lines. This will give you your, what your compass is going to follow. And
What up,
again,
new perspective?
this is what your latitudes, or however you want to say
What's
it,
up,
your
brother?
declination from whichever central location of whichever
Fella, man,
pole
good
you're
to see you out
using,
here.
north or south. So Polaris or Sigma Octavius. Um, these would be those lines as far as these full circles.
See
Yeah.
how
See
is
how they're
Erica Kirk
outlined,
really Benjamin
right?
Netanyahu in
Because of the
drag or what?
donuts. They're literal donuts that are running within inside of the magnetic field that are pushed up together here in the center and not pushed up against anything on the outside.
This would explain
There
the
you
You
go.
can
And those
see
the
how they
those
look.
stars.
circumpolar navigation that
One
satellites
second.
would do,
Go
and
ahead.
that circular route. That circumpolar navigation that the satellites do over the circular route like that, and that reminds me, if you go like around these two like little points, that looks like the exact route that they took whenever they claimed they did circumpolar navigation. They really did navigate around the poles, but they didn't go from one side to the other. You see what I mean?
Yeah, they didn't go down the international date line on the blue side of the ball. They can never do that. The international date line goes halfway north of north and halfway south of south. But on the ball, they pretend like it meets in the back, but it never does. You just go around the south or go around the north, and then they have to
Mhm.
switch the time over when the sun starts circling in the south. There's a whole thing he talks about where like there's a difference in the way they start time and end. Like noon is at the prime meridian, and then midnight would be 180 degrees where the international date line is. And there's a whole thing about that. And the way they deploy the satellites with the charge, because they're using these electromagnetic fields and actually putting real things up there. So it's not like all satellites are on balloons. It's like they're actually using this field to circle at either the north or the south. And he says that like if you're involved in deploying these satellites on an intricate level, you would have to know which side you're using because there's a difference in the way the charge would meet the way you would use the satellite has to have the right charge to use the field correctly. And it would be a difference in the south or the north. Anyway, I think I sent these to you, Issa, didn't I? I sent them to pretty much everybody I knew.
Mm-hmm. I'm sure you did.
I don't know if you're still here,
People
Issa,
send me
but yeah,
stuff
I
all
sent
the
these to
time,
you.
and I can't watch it all. But this is
Oh, yeah, I know
interesting.
I sent you. Yeah, it seems like he might be on it. He might figure something out.
It makes a lot of sense. I mean, I guess the only thing people would contradict is what, like the flight routes or something.
No, it's exactly, that's the
I
thing with
mean,
the
there's a
transform. It's
lot.
exactly point for point. No, but the GPS coordinates. This is the graticule they use for all practical purposes, and there's no difference whatsoever in the flight routes or distances. It's point for point, exactly the same as it would be for any flight that they say is going around the globe, because they're going across that whole blue side of the ball. And when they do that, they're either going around the North Pole or around the South Pole, and it's the same thing. It's just the water's out, spread out, rather than on the other side of the ball. And it's exactly the same distance. There's no difference. If you want to play a shorter one, he talks about that directly. Or you could keep going with this one.
Well, is this more of the same on this video?
I'm not sure exactly because I haven't watched this one for a little bit. I'm not sure how much more he
31.
goes into it. Yeah, let me give you the shorter one that, yeah, let me give you the other one. That would be better to play maybe now because he goes into what we were just talking about. Hold on.
Hey, can you show that last part one more time? Because
Let's
Dan
say
just walked up and wanted to see the. Just rewind to like 10 seconds. It shows like the Earth map and then the two poles he put on top of it. Just like the image.
Yeah, just super quick. Thank you.
Wait, how long did he? There we go. Okay, that part. Like rewind it just a little bit more before he puts it on there.
Land and everything is general.
As
Yeah, you're good.
whatever
You
it
can
is, the
just start there. You
declination,
can
who
see.
knows, whatever it is. It's 23.4 degrees as far
Right
as
there?
whatever it is from here to here.
Yeah, yeah,
And you know
fine.
that the distance is here.
Does he take the
And you were saying
top
the
pic?
altitude in general, the altitude of everything in general with the sun.
Here, let me. I wanna fix something real quick. Let me improve this.
I put the short one in, the other one in the chat, by the way.
There, this should help with like the resolution should be a little bit more or whatever. So.
You just
And the
want to see the
toroidal
map.
field and the land and everything is high.
Is
right
this not
now.
it? I thought this was it. I'm asking. I'm doing this for you,
I'm not
Taylor.
sure what
So
you're talking about.
I don't know. She's not talking now. So
Oh, I was muted. I said the map without the lines on top, but it's all good. Keep doing whatever you're doing.
oh, okay, okay.
Maybe you should just play the one I put in the chat because he kind of goes over
Is
some
it
of the same information
okay? Give me a
in
second.
this one that.
I got to respond to somebody. Give me a second. Okay. You said it's right before this?
I don't have any clue. I was just asking about the map without the lines on the top. But it's all good. Don't worry about it. It's still you could still make it out.
Okay.
Yeah, he takes it away in
That's what it has
the
to
next video. You know, you came up with
Okay, so this one's excerpt on map coordinates, magnetic declination, and flight direction.
your understanding that the sun's doing the figure eight way before TFE was even thought of. By the way, like you knew it was going in a figure eight, but the timing on this now coming to light with your map and the 24-hour sun working on a dual pole, people often are just gonna throw it away as it's almost like it's too in your face because it looks so much like the globe. It matches the globe one for the coordinate system. Oh, explain Hawaii to us about the coordinate system real quick. Now that I thought of it, Hawaii to New Zealand. The people are saying that it doesn't make any sense with your map. How are they going on on an airplane from Hawaii all the way down to the other corner, which is either New Zealand or Australia?
Okay.
A
Well,
lot going on there.
let's go with this. You were talking about something. I had my mind on something else, and I forgot what I was going to say. But let's go ahead and go with this. So on my map, I know that my Hawaii is off by about 10 degrees. It should be up here. I just have to do the corrections of the equidistance to the polyclinic mix to make it right. But this is where I believe Hawaii is going to be sitting right here in the northwest quadrant at 155 and
That's
20
way out there.
degrees or 20 degrees north latitude.
It's like at the edge of the
If you're going to go
world.
to New Zealand or Australia, you're just going to follow the track just like you would.
Huh?
How did he get Hawaii up there?
It's off the coast of the U.S., just like it would be.
Oh, okay. I'm gonna look at all the flight routes. Cause yeah, they don't go south once they hit Hawaii. But I mean, this is obviously up for change, right? If there is something wrong.
But yeah, it's just a coordinate system transformed. So I mean, the way they'll show it on like the flight path going across from Hawaii to New Zealand is across. Well, here he explains it right here. I question him on.
Would on any map that you're going to use and follow the GP to go west.
how can I put that? You're going to
Yeah,
go
well, they have
west,
it
and then
on the maps. They're showing it goes straight across the international date line in the diagonal form, like that. Yeah, right
right.
to left. And
Okay, well,
people
this
need
is
to
the international
understand
date.
this is what we were talking. Yeah, the international date line starts there. So even though you're going around the top, you're still going west, even though you're going left to right. And that's what people need to
Yes.
understand because it works the same way. Just because they're showing you the coordinate system with a diagonal going, down from right to left, even over the middle, and I don't know exactly how that would work, but yeah, so if it goes over the middle, then that's exactly what it would do. So just draw out the path of a flight that goes from Hawaii to New Zealand. Yeah. Now it's going west, even though it's going the opposite direction of through the middle, because the international date line coordinate system makes it work that way. That their coordinates are going east to west always, east to west around the
Right.
circle,
And
the
I want to
clockwise
also
circle.
show you too. I also want to show you too. I am going south when I'm going this way. I'm not
Yeah,
going north because north is this way, is to this
yeah,
point. North is
right,
not here. So if you're
right,
going from here to here, you're going north. When you're going around here, you're going southwest.
right. Because the coordinate system works that way for it to lead to the south
Yep.
along those magnetic field lines. Right.
And the funny
Yeah.
thing about all this is the main thing that you have to realize is it's not that I'm saying this is what it is. This is what it is. If you take a compass, you cannot use a compass on something that doesn't use two poles. You have to have a north and a south. You can't have a ball. You can't have a disc, a pie plate that doesn't have a south pole because you have to have
Yeah, you can.
declination. And that's what gives you your declination. As soon as you get away from your prime meridian, you do your equation of your, it's called your declination equation, which is just I'm not going to pull it out right now, but it's just an equation that you do to wherever you're at your longitude and longitude. You do this equation, it gives you your declination for your magnetic heading. Well, that won't work on anything other than a two-pole grid system that has a north, a south, an east, and a west, a four-quadrant grid. That's the only way you can do it. It doesn't.
And you were saying
There's
it only points. The compass is only going to point north, and that's part of the reason people think, oh, it has to be one pole. We only see one pole with the compass. Explain that.
yeah. Well, so a compass can only point to north because it's only going to the positive part
Polarity.
of the magnetic
Yeah.
field. But so when you get into the southern part, you're pointing north, but it's following the same magnetic field. It just follows it opposite of the southern pole. It's not like you have a compass that points south. People
Uh-huh.
might want to go, oh, I got my compass and look, I can point it at 180 degrees. No, you're pointing at the opposite end of the needle. So your
Right.
needle is always going to follow these magnetic field lines. And
Right.
it's not a question of whether it is this way. All you have to do is look at any of the polar exploration, any of the Antarctic exploration,
Uh-huh.
and what did every single one of them do? Every single one of them that went to the south traveled, no matter if they came from America or New Zealand or anyway, they went all the way around to 180 or 150 degrees and then started going up so that they knew that they were at the international date line. They knew that they were at the furthest east, no more west than they could go as far as, I'm sorry, they went as far east as they could go and not into the west. And then they started going up to the southern pole. They did the same thing with the North Pole in the 1800s. So I mean, you can see that how all of our explorers worked, all of our admiralties convincing of the world to change the prime meridian to the UTC or the Greenwich Mean Time. All of this was done because it is a two-pole system. It couldn't have been done any other way. You can't have
Right.
a one pole. You can't have a magnetic field that doesn't meet up with its opposite or its opposing field. It
Yeah, I think
has to.
people are. I think that's one of the things that lends people to favor one pole because of the compass always pointing north. So if they're in the south, real quick, just to clarify, if they're in the south and they want to go around the south in the same way, they're not using the South Pole as a compass reading to go by. They're still pointing to the North Pole and using it as a way of getting around the south. So they'll be able to know their heading and their declination and everything, regardless of the poles. But if you're using a compass, it's not like you can go around the south in the same way you can go around the north with a compass, right? Or how does it work?
Oh yeah, no, you can. No, you can go around the south and using your compass.
Right.
You're just
Okay,
going
but
to be.
where is
You're
it
going.
pointing then?
It's pointing north.
Right. Okay.
So when you're going around, it's pointing like this. If this is north,
Uh-huh.
right, and you're sitting here, it's going to be pointing like this. As soon as you walk over, let's say you were at the South Pole and you moved 1,600 feet to the south of from here. You know, you actually you're at the South Pole and you moved that much distance. Your magnetic field or your compass would point this way. So you can use
Oh,
it
because wait,
as
hold
a
on, wait. You're
southern
saying
compass.
it points to the outside because that's now north in the same way south was pointing out from north in the south. I mean, in the north.
There
I
you
mean,
go.
south was pointing.
There you,
Okay,
right, but
so
you have to look at the magnetic field. It's not just always pointing out. It's the
mhm.
declination from how far it is from the prime meridian tells you how far that declination is. It's going to be the same as the north, but you can see that here, right here, if we were sitting here, we could literally sit there and move 100 degrees and our needle will stay in point south
and
or
that's
point north.
and yeah, so that's where people really they get so set on discarding the idea of a two pole because of the magnetic declination showing there's just the North Pole. It's always pointing north. If there was another pole, we would see all kinds of crazy compass readings in the south, or magnetic declination wouldn't work the same. These are some of the things that I think get people sat on the idea that it has to be just one pole in the center and everything revolving around that, because that's what
Right, but
a lot of things are seem to be showing with the compass and interferometry coming from one source and all that kind of stuff. But it's just one circuit that works with the north and the south, which could actually give you, the misunderstanding of it being a one pole system.
so you can see though, it's when I talk about magnetic declination, I'm not talking about something I'm figuring out or that I'm guesstimating. There's an actual equation for your compass error, and it is sin. And these are calculus or scientific calculators that you're going to have to use to do this, or you're going to
Right.
just have to do it in your head. But these are trigonometry, but sin multiplied by the declination, and that's just the declination of U to Polaris. Divided by the cos to multiplied by the latitude. And then once you get that actual amplitude or whatever that compass error is, you multiply it by 60. And that's the amplitude. You multiply it by 60 and that will give you your compass error. It's not something I came up with. This is well known in any type of astronomical or any type of topographical mapping. These are things that I didn't come up with. You can find out your declination, and you have to have a two pole system in order to do this. There's no
Right.
magnetic declination on a one pole or a ball. I mean, I'm
Right.
sorry.
And this is another thing that keeps, people convinced that it's a globe because of some of these things that they think the flat earth doesn't work with. And that's what's so interesting
Yeah.
about this, because it's melding the two ideas uh, in the way it has to work, not just the way you hope it works. There's some kind of speculation about trying to make it work for your layout that you want to have. It's just, this is how the data shows it must be. And it works perfectly with that international daylight half and half. Now, getting falsifying your model, like what would you say could falsify your model if you're going to do like an internal critique, as far as what would show you that this isn't correct, or what would be a way that someone could take this and test it.
Well, there's no way that Nemi's going to be convince me it's incorrect just because if I can plot my position and navigate with my map now better than anybody can with the stars today. I mean, I've really changed that. But what it comes down to is when I started doing this, I did the map like this, and you can see that this is with Greenwich Mean Time as being the prime meridian. And then as soon as I realized that it worked, I could use it, but it wasn't working out as far as time frame, as far as the sunlight and the star patterns for when I could do my declination and stuff for New Zealand and Hawaii. And there was one other place, and Tonga. Tonga was the other big one. As soon as I started doing the research into it and looking at Babylon, Sumer, and Egypt, and realized that it was that prime meridian and moved everything, you can see that everything, like New Zealand, moving from all the way down to all the way 33 degrees is all it was from here to here.
Yeah.
33 degrees movement, and now you can see that it's. I'm not saying it's perfect, but it's closer to what it needs to be in order for the sunlight amount of sun per day in the winter solstice or the summer solstice for New Zealand to get was starting to become correct. The same way with Hawaii. But the main thing is that the sacred geometry that I was using to find this information, or that I was coming across to explain what was happening in the sky, explain why the megalithic structures were all the way they were, why the pyramids were built. It didn't work out on this one. It worked, but it was skewed. All of everything was skewed off. It was all leaning down this way. As soon as I moved that 33 degrees, the pyramids, the triangles, the circles, the squares, the lattices, everything started matching up to where it should be to make sacred geometry. And that's why I think that it needed to have the 33 degrees moved.
Yeah, and more technically, everything works as far as coordinates go, and as far as falsifying your model, like I was saying, like anybody's going to come and say, what's if this is your proof that it's this way? What can I do to falsify it? Like we ask a glober. It's intuitive. It works just like the globe. So I mean, all the math's there. There's not really any way to like debunk it in any way for the coordinates, I guess. The sun
Not
has
coordinates.
certain
The only way to
degrees.
debunk it right now, anyway, that I can see, is when you get out here. When I get out to 160 on either east or west, or I get to 180 and 180 and 0 top and bottom. These are the places where my anomalies happen. This is where I can be off by 2,000 miles by my mathematical equations, not by putting my star maps on top and using them and doing my triangulations. But if I try and just do all mathematics and equations, I'm off usually by about a half an inch or about 1,000 miles out here, down here, and up here.
And that's because it's a kind of as far as the compass readings go in those areas, plus just the information you can gather, it doesn't really seem to necessarily be as easy to grid on your map.
No, it comes down to this. I mean, it could be that. It could be that I just don't understand it very well. I might need to be a little bit more a little bit more versed in complex trigonometry and shit like that. But when you start taking, like, you can see this grid map right here, this would be like a 0 degree or a 5 degree latitude. You can see that what it looks like here at the celestial equator, where everything is, right? If I spin it out to where now I'm out here, you can see it doesn't even come anywhere close. But it has to be like this because there's no way to get, it has to be within inside of this 360 degree circle where this position of the observer's viewpoint, right? But that observer's viewpoint would be 0 here. This is 0, but this is not 0. 0 is here.
Gotcha. So yeah, and it's almost like because it's in that more well-known areas that you're able to confirm some of your speculations with where exactly the land should be and all that.
Right, and the whole idea is, so, like I just showed you with that and how far off it is, and so I can take this and go to here. The reason this works, even though it's off like that, is because you don't go by this observer proof point, you go by this entire line.
Okay. Interesting.
So I know that I'm at 100, 100. Well, I'm not. Okay, so I know that I would be at, let's say, 90 degrees latitude or longitude, right? That, and I'm saying I'm at with this one, the 45 parallel. Well, that's not at the 45 parallel. That's more like at the 50 or 55. So you just go and follow this line down to align it up with it. You still use this as your measurements. You still use this as your viewpoint, but you line it up out here with this line.
Gotcha.
And everything still works. So the map works, the triangulation works with everything, the overlay works. The problem is when I remove all of this and I grab this information, all of like the 53 and 23, and I remove all of this down to data, to actual mathematics. That's when it goes haywire when you get out here.
Gotcha. It gets a little bit obscure or hard to be positive about certain things. And those are islands, like
Well,
you were pointing out, like where Point Nemo would be on your map, which is supposed to be right in the set, like in the Point Nemo would be out there. As far as the grid, the coordinate system, it's in the southwest
no,
coordinate system.
the grid system is right there. It's southwest. Yeah,
Yeah,
it is.
southwest. Yeah, they have a southwest coordinate, and that's how it would work out on your map. And so I guess the way to debunk it would be to go somehow directly west or east, and one person walks from the center west, and the other person walks from the center east, and they both meet at Point Nemo. Right now, they would be able to do that on your map, but they would go around the ball to the top and back to around to the where Point Nemo actually is. But the idea of the ball is that you would be able to walk east or west and meet on the other side of the ball in the middle of the blue side of the ball. Right? That
But
would
they
be a way
can't,
somehow.
because you can't. So if I'm here, right, and I want to go here, and you want me to go there by going east, okay, going this way, you can't go this way. Your compass will take you this way. This is east.
Even though the
This
compass,
line right
and I'll
here.
explain that, the compass is going to take you around the south, but it's still pointing to the north, right? The compass.
No. What? Okay, yes. I'm saying if you're trying to go east, if you're here and you're in the southern and you're trying to go east, your compass is going to take you around here. It's not going to take you this way.
Yeah.
East
And
isn't
just like
here.
we were saying with the top, east is going around the bottom. East is still going around that direction. Yeah.
Yep.
And it works around the poles. If you're going around clockwise or counterclockwise, one is east counterclockwise and one is east clockwise. If depending on which hemisphere you're in.
Fingers are making me laugh so hard.
That's what really is.
The what?
The way he was doing his hand was fun.
Is the crazy obvious
But it
thing
makes
of how it
sense.
would have to work with a flat Earth. Oh, I made like a directional thing with his map. I'll put it in the chat.
I think I've seen that before. Yeah, I think he posted.
And two poles, because that these people can stay convinced that it's a ball because look at it. It looks like a ball Earth. Because part of the reason that flat earthers have a problem with the two pole is they see globe. They're seeing the globe right here. They're like, wait, that's a globe. Look at it. It looks just like the globe they're showing me, pretty much. And that's why it's such a brilliant illusion.
The minute you take this all apart and then overlay those star patterns on top, I think it shows everybody what's happening. I can't find my star patterns now.
Yeah, this is the real debunk for the globe. It's funny that the Southern Stars used to be our go back in 2017 when we were talking about the Southern Stars being a real thing. We were leading off debates by talking about the converging and diverging star trails. Like, there's no way this works with a glob. They can't diverge and converge, and you can see it in the sky. And we don't have to get your computer out, but maybe in a bit you could show those different shots you have where you can see it as you go out east or west of the prime meridian. You're going to see the stars start to pull apart from each other, which wouldn't work on a globe. And I think what's their excuse for that? Do they say it's because perspective, or just the way that it's a phenomenon because it's going around the ball and it starts to look as though they diverge. Is that their excuse?
Yeah, they
I
say
don't
it
know.
doesn't. They say it not diverge away from each other.
Oh, okay. So they claim it
That's what
doesn't do exactly what we can see it does.
exactly.
So
Yep.
that's pretty risky. They don't have
Hey,
that
I'm
worked
gonna
into
have to
their
pause
model.
it, man.
Yeah,
Pause it for a second.
yeah.
Pause it for a second.
Oh, okay. I'm going to start. Okay, I'm recording again now. So yeah, you're saying.
Okay.
All right. Any other juicy bits, or are we good?
Yeah, I can give you another juicy bit.
Ah, Dave's
So,
Beavers.
I got lots of juicy bits.
this would make more sense with like the size of Antarctica and stuff, and the size of Australia. Like because they say
Yep.
Australia would be stretched out.
Yeah, and you see that exact configuration. Like you, if you look at his map long enough, like I have, you start to see that that's the configuration where they show all the continents at once. It's pretty much exactly the same.
Mhm. Yeah, it's definitely interesting. And I like
It's so
he set
weird.
up. Did he draw everything that he's using? Like he made it by hand, or did he order that?
Yeah. No. Well, no. The printout of the stars and stuff he printed out are more analog.
Wow, that must took a lot of time. That's really cool.
Yeah.
What like
Uh,
does he come on Discord much?
yeah. He was on Earth Awakenings a couple nights ago,
Oh,
explaining it, some
cool.
of it. He'll
I
come on
think
here
Gio's
even.
pretty convinced, huh? Gio believes in dual pole.
I don't know if he said. I don't know if he necessarily believes in it, but he thinks it has to be a dual pole. He's tearing apart, and he kind of questions. Doesn't want to like commit to anything that doesn't necessarily check out 100%. Everyone's model shy. They don't want to. They don't want to go two pole because if we were tricked with the AE map, or not everybody was. I think any flat earther was saying that we don't have a model. But they try to claim like every flat earther was an AE mapper after the TFE thing, which wasn't true. But if it's an AE map, it has to be exactly that. You can't, because if it's this transform of the coordinates, you can't just have it be something like the AE map. It has to be exactly like the AE map for the coordinate transforms to even work. So, and you can't have a circling sun if it goes two different directions. So it has to be a two pole flat Earth. I mean, that's the options we have right now. It seems like whether it's exactly like he's saying or not is the question, and some of those things could be, need to be verified. It's not like people should believe anything. They shouldn't just believe what he's saying. They should go look at the nautical information and check to see, if it all checks out, or do some, work of their own, kind of like he's done to verify it. Hold on, then we'll play that one. Hold on a sec. You could play some of this one. This is the longer one. This is the better one, though.
No problem.
There you go. You can play
they're
that.
all getting they're all getting longer. 1 hour 16.
Yeah, well, we could do it double time if you wanted to play it faster, or you could fast forward through parts that he repeats. But yeah, you could play some of it. If you wanted. I haven't shown this to anyone yet. This would be the premiere of anyone seeing it.
Oh, this is hot off the press, huh?
Yep.
Let's see what we got. Okay.
Twice as
Let's see what
long
it
from going,
see what
all the
it's
way
like.
up from Hawaii down to, we already covered this, but just give us a little quick showing of how the magnetic or your compass
Well, and
reading
I want to say one other thing as
your
far as that goes, as
grid
far as
system.
the distance. The distance is the exact same on any map because my grid system is exactly the same grid system that is on any azimuth equidistance, any cylindrical, any Gleason map, any AE map, anything. These grids are where they are. There's no changing that.
Yeah,
That
they're
means that the
transforms.
distance
They're
between
transforms
here.
of the graticule, right? Yeah, the graticule is a
Right,
transform,
but I'm
and it
saying
has its own
so
coordinates.
that means the distance between here and here is the exact same as their map. It's
Yeah.
just a representation of where it is. So when you want to go from Hawaii to New Zealand or to Australia on my map, you're going to go west and southwest, directly the
Yeah.
same exact miles as it is on any map.
And people think that, wait, hold on, you're not going west, you're going left to right. It shows it on the
Right,
map. It shows me going
hold
right
on.
to left. Yep.
I understand, but this is not how you use this map. You
Yeah.
can't be looking at, and this is your map. If you were in Hawaii and you were going to be going to Australia and you're using my map instead of just looking at my map and trying to draw a line on it, you have to put yourself with your positioning towards north up. So
Yep.
this is how you would use my map. Now you are going west.
Yep. And you're going down in the same exact way. And it's a diagonal thing. That stitching where they stitched the international date line from one end to the other and bent it around the back made you think that that line goes circumpolar navigation right straight through back up the back of the ball, and then they did the same with the east and west and pulled those around like a bald guy with a toupee.
They did this.
Yep. Yep. And that's because we're looking at a magnetic field, an electromagnetic field, which is exactly what it is. And they realized they could just confine it, and because maybe there is something that we don't know, uh, as far as like going outside these perimeters, right? Maybe there's some kind of danger, outer ponders, whatever it is. They probably justify the
Hey,
illusion in that,
quick.
well, we can't go any.
Yo,
How do they think the magnetic field's actually generated? Because, I mean, we know it can't be liquid metal because the Curry point, and it definitely can't be,
there's
nothing
a
like that. But I'm wondering, like, yeah, go
liquid
ahead.
dynamo theory.
Mm-hmm.
God,
Yeah, I don't know how it works. They're not even sure how it works,
if
but
this if,
they know
if
it
this
has
is
to
how it
be
is,
unlike anything else going on.
if this is like a perpetual motion machine that has the sun lighting up all of this area is like perfectly, it's like the perfect atrium. I mean, it's proof of God or whatever it is. Like it's built. It seems like it's built to work exactly like this.
Yeah, I mean, either way, it's miraculous for sure.
Nah.
Anywhere else anyway. So we're going to give you the space fantasy. People don't like to feel like trapped in a cage, like a rat in a cage or whatever. They don't like to know that there's nowhere else to go, like that because we're confined. Maybe psychologically they think they're justifying their premise that that is the illusion. I'm not trying to say that they should or that it's okay. I'm just saying it seems like I probably
Ugh,
am right about
sorry.
that. They justify it by saying, well, this is the illusion we were inherited. We inherited, and this is the reason that we're going to keep this coordinate system with the graticule and the idea of the ball alive because materialism and everything else that they're trying to make sure people stay with, regardless if it's a evil conspiracy or if it's just a convenient model. Either way, this definitely is a reversed ball Earth coordinate system.
Well, they can't get away from the coordinates. They can't get away from, because the latitude is only done because of what you're measuring your angle at of Polaris or Sigma Noctantis.
Right.
It's not. It has nothing to do with any.
Is he like Canadian or something? Yeah, I was just curious about the pronunciation, man. That's all.
Magnetic
Yeah, I don't know
measurement or
exactly.
anything. The magnetics is done from, as far as our latitude is done from the magnetic readings, but that can be done from any specific point. You can have the prime meridian anywhere as long as it comes back
Full circle.
360 degrees. Yes, but the problem is if I put the prime meridian here, right?
Yeah.
Then all of our marking of time as far as the sun through the stars doesn't work, because this would be the prime meridian. Then all my magnetic declinations for my equations wouldn't work. You'd be off by about 12 degrees.
Yeah.
Your magnetic declination. And here's how I know that it didn't work that way, because if you look at the star patterns, or you look at the star charts, I got that upside down, and you look at what they have. Now, this is another one of the star charts that is this same information that I have on my star wheels. It's the all of it's exact same information, except this is in a linear graph. This is in a cylindrical, or I'm sorry, disc graph, right?
Oh.
Okay. So what they did is you can see that Polaris is 33 degrees from the vernal equinox. This line right here is the vernal equinox. This is how we mark time from one beginning of the year to the end of the year. All the celestial constellations, or vernal, or not vernal, I'm sorry, like Leo and Cancer and
Capricorn.
Virgo, all those are along this entire wave, 1 through 12 of them across this graph. Well, they started that graph 33 degrees off. And just like I would say, if you were to redo it and you move that 33 degrees back to the prime meridian, back 33 degrees to Egypt, that would do exactly what I'm talking about here. That would move that Polaris back to the vernal equinox, to where all of everything would start here instead of up here where they've done it. Do you see what I'm saying?
Yeah, the sun has to move through the constellations starting at a different point. It's the same wave, but the wave should start back at where Polaris is rather than where they moved the prime meridian to, and it messed everything up by 30 degrees. So everything kind of works, and you can still plot everything out, and it's similar, but that correction is kind of unnoticeable almost, is what you're saying, as far as your compass
No,
readings from
it's
your.
not. No, it's totally noticeable. It's not known because they took and they moved it 30 degrees on the star patterns. So the only way you can see that is when you go visual. So nobody looks at stars like this. You don't go outside and you look at the stars and try and figure out by a graph like this. You don't go
Right.
out and most people don't look at them like this, right? These
Mhm.
are off by 33 degrees. They've moved it 33 degrees, the numbers, 33 degrees. The same way with this. When you go to sidereal, this Polaris, or these numbers, these stars, their sidereal is 359 when it should be, I'm sorry, 327 when it should be 360. You see what I'm saying? They've
Right.
moved
So
everything, even so in the nautical almanac, the actual numbers on the thing, the sidereal has been moved 33 degrees.
interesting.
So you don't see it, you don't know it. What you see is uh, Greenwich Mean Local Hour, or GHA, and it'll say 327 degrees, and the next one for Sigmund whatever or Vega will be 120 degrees. Well, that's 33 degrees off of what it actually is from the vernal equinox, not from Greenwich, because they
Right.
moved Greenwich. They moved
Right.
it, and they did 1747.
So that was a way of basically masking the true position of everything, just enough so that they could, basically make it very hard for everybody to really know exactly what's going on with the sky in relation to the Earth,
Yes, but that's not the reason
navigation
they did
wise,
it.
even. Okay, go ahead.
That's
Explain.
not the reason they did it. They did it because they wanted to be the center of the control. So the people that had control before them, even if it was France or Rome or whatever, they all used the prime meridian. They all used Egypt as the prime meridian because that's where the rulers and the people who came up with all of this stuff were from. That's where everything was from. But when the admiralty, the people that took over, I don't know if anybody knows what the admiralty is, but they were the grand poobahs of the England and the ship captains, and the admiralty was a big conglomeration of the people who started the Freemasons, pretty much, if you want to get down to it. And they wanted to be just like every ruler wants, the center of everything, the start. They wanted everything to be under their control, so they moved the prime meridian, that all maps from then on, from that time on henceforward, and all times of the world, as far as the clocks and the latitude and longitude, would be centered on Greenwich Mean. And Greenwich was in England, was where everything, all of the admiralty started building all of their ships that controlled the world at that point in 1700s.
And this limited the common man's ability to navigate, you were saying?
No,
Okay.
it centralized everybody together. So all of the maps that worked before either worked off the prime meridian, off of the central location of the country. So let's say China or South America, that's where they started their maps from, or they used run lines, whatever, however you want to call it, run lines, whatever, that were lines between each location. They didn't have a latitude and longitude. You couldn't sail across from wherever you wanted to wherever you wanted. You could only go from point to point. That's why they did it. I don't hide the world. They did it so that they could centralize and
Control.
not compartment, but get everybody under the same latitude and longitude, the same way of looking at the world. And it was going to be them that were the center of attention.
Because there was that, yeah. Now this allows, and I think what you were saying is it made them kind of dependent on the people that really knew where the prime meridian was in some way, because they were able to not just go point to point by rum lines, because rum lines don't allow you. That was another thing that I think you said to me in an off camera conversation about the rum lines. It only allows you to go point to point. It doesn't allow you to go,
Right.
know where everything else is as far as the stars go in relation to where you're pointed.
No,
Right.
yeah, it does, and it doesn't use the sun. You can't have any timing. You don't have any starting location, or you couldn't have you couldn't change in the middle of your trek. You
Right.
had to go from point to point. Okay,
You had to stay
well,
on
that's not why they wanted everybody to do that. They wanted everybody to do that so that they could use everybody's maps. Everybody knew what they were talking about, and then everybody would be using the Admiralty's set standards. Everybody would go by that instead of their own way. So now you couldn't hide islands. You couldn't find places like the pirates would, have certain places that nobody knew about. Well, if you had a map, now everybody's using the same coordinates. Not that they would want to reveal it, but just having those coordinates and everybody using the same coordinates, all of a sudden now you could find out where everything is. You know where people are at. You know where they went. You know where they were talking about. It's how.
So yeah, so it keeps it almost like introduced the whole surveillance.
Bro, there could be so many places that they're just like keeping for themselves, Like I know I keep saying more land, but for real, it's got to be way more land. It's a whole different feel.
There,
Opportunities
you got it. Yes. Because if you couldn't know anything other than this brand dangled fucking new coordinate system that everybody could use and everybody knew, and you knew you were going to get to where you were, would you use it, or would you just go, oh no, I'm going to use my seeing stone?
Yeah, exactly. Yeah, they made it the most useful thing, even though it was not correct in the way that you would need for just independent exploration.
Oh, no, it was correct. It was definitely correct. It was just off that 33 degrees for the geolocation, as far as that you wouldn't be able to associate it with the esoteric or the sacred geometry with the stars with the geolocation of the. I keep saying geolocation, but that's not right. The uh, land masses. The where the land is, as opposed to
Geographical.
where the stars are, as opposed to where the magnetic field is. It doesn't matter if you change that magnetic field. If you change that prime meridian, it still all works great. You can still do everything exactly the same. It's just you can't reverse back to the basic starting point because you don't know where that starting point is if they changed it. That's the only difference. I can use
Okay.
I can use their grid map exactly like it is, latitude and longitude, off by 33 degrees. Everything works fine in the stars. Everything works fine in the sun. It's just when you try and map it on the ground.
Yeah, with the sun
That
and the stars together, everything is one complete. Um,
there that's
yeah,
yep.
everything's out of sync. Yeah. So by putting everything out of sync, it made everyone dependent upon it. Now the GPS, of course, with the graticule, they've got it locked into this spherical coordinate system, which you know is the key to the whole GPS and everything, making the idea of the sphere. And someone might look at this map here, and they think, and they could very well think you're just looking at a globe that of course it is a transform to some degree, but in the 33-degree correction, and you came up with a graticule transform of the two-pole system before I even showed you that there was these maps online about the graticule being showing two poles and how it all works out. It's just a transform, as Shane St. Pierre would say. It's not showing you a new model, it's just showing you a transform of the coordinate system. Well, this one happens to
Right.
be the most correct one because it gives you the 24-hour sun, it gives you the the southern and northern stars diverging and converging, and all the coordinates of the globe are correct because it's not a globe, it's just this right here that works with
Yep.
two toroidal fields, and that you're circling around either north or south, and all the coordinates
And it
work
kind
just
of
like the
makes
globe. I mean, it
it kind
makes
of
sense.
makes more sense to be this way because it's simple. It's the most simplistic thing that you can. All you had to do was take their fucking globe and smash it flat in their 24-degree angle, and now you've got south and north, and
Yeah,
all of the images of everything falls right into place.
yeah,
It's very simplistic. It's the most simplistic thing I've ever seen. As far as, like you said, when I looked at it, I said the same thing. Or I shouldn't say, not that's not right. When I made this, I kind of thought the same thing, but I didn't say the same thing. My mother did. My mom said, "Well, that's just the ball Earth."
yeah, exactly.
When I
Right.
showed her, and I
Yeah,
was like, "No, it's not. It's flat. It's just like you see it." She goes, "No, no, look, it's circle. You got it.
yeah.
It's just like
That's
a
what I was
ball."
getting at.
And
Yep. That it's like it
I was
lends
like, "No, no,
itself
this is
so
flat."
well. Yeah, it's the perfect
And I
illusion
said,
that they realized. They realized they could sell this as a ball because it looks like a ball.
"Right, but you
But
have
the
to
magnetic
remove
field
my graph.
gives that illusion. Yeah.
That is what the world looks like. The only reason it looks like a ball is because you put the magnetic field on top of it."
Yeah, exactly. That's the illusion. And the magnetic field looks like a ball. Any of these we can show you one after the other of what a two-pole magnetic field looks like, and this is what we're seeing in the sky and how the magnetic field lines, the declination and everything works south to north, one direction, one source of light or one source of energy for the interferometry with the can you touch on that? The interferometry, I brought it up. The light that the interferometry is showing one direction east to west, and everything's coming from one source. This is another contention people have with the dual pole. They think it would be thrown off by the southern pole.
That what would be thrown off by the southern pole?
The interferometry readings would show more than one source. Like you have, it's another, you know, idea of another pole acting as a pole in the same way the North does, and we went through that a little bit already. Everything runs south to north, so you're only going to see the compass pointing to the north, one direction of the one circuit, which is the south to north. It's one circuit, so it can give you the illusion that this is, again, one pole rather than two poles.
Well, I'm going to have to just go through a couple images. It's the only way I can do it to get the right ones. So, come on. There is diverging and converging depending on, this would be the celestial equator through the center, and then you would have the North Pole and the South Pole. And you can see how they diverge and they or converge and then diverge depending on where they are. This would be the prime meridian of where they're at within side of the circuit going around.
Yeah, and everything moves east to west. Go ahead.
Well, the same way that you would see within side of any electromagnetic field, that within side of the magnetic field, if you're using a two-pole system, whether it be a coil, a wire of connection between a medium, or how it is, if you grab that item from the positive or from the energy, this would be the South Pole, this would be the North Pole. It runs with the rule of thumb. The current does. The energy will run from the south to the north, from the positive to the negative, and it will always be on this side a clockwise rotation of the movement of the magnetic field on the north and a counterclockwise on the south, or the positive, however you want to look at it. So you have a converging on the input and a divergent on the output, and it always moves this way. It never goes back. If it's positive and negative, rule of thumb tells you that the current will always run with the rule of thumb, and that means you have this exact movement. Now you put this with the magnetic field that you use with your compass. So this is the magnetic field you would have in the from north to south, and you can see the latitude or the longitude lines will connect the southern pole to the north pole, and it does it exactly as the longitude lines of my map does right there. You can see that if you put it sideways, you see that same exact, here, I'll even remove, so you see the exact same thing. There's that line, there's those lines. So you would see the exact same thing as far as how it works. Well, you can see that up here, these lines aren't curving. That's where your magnetic declination, or your what you would call your flux, gets out of whack, and that's why you have your up there, or I have on mine, to where you have it to where it bends really weird to where your compass will dance in these areas.
Yeah, that's crazy.
I think I got off topic, but
no, that's great. That's great. That's exactly what we were talking about.
So,
go ahead.
well, I was also going to say, so you can see that on an
The two
normal,
heads.
just what would you call them? Say this is a cylindrical map, just a linear map of the time zones, and you can see that they're separated by 15 degrees. I mean, literally 15 degrees each time zone is, and that's how you can see that this isn't how the map is, but that's how they would have to split it up, the same way that I split it up, that you would have the 15 degrees of your declinations from the magnetic field that you see here. Here.
Yeah.
The same thing. But that's how you get it, and it starts from the prime meridian, and then you have your international date line the same way you do on this one, where you have the prime meridian and the international date line.
Yep. And everything runs north. Everything in the same way that the AE map says everything away from south is north, and everything away from south or north is south. But it's not going to the outside perimeter in this case. It's going actually around the field lines, and even if you're pointing, north of north, technically the field lines are going to pull you south in the same exact manner.
Yes. Yeah, it won't matter either how it works. It's going to pull you towards that South Pole, whatever fashion it needs to. I'm trying to pull up. Where is it? I was trying to pull up the analemma. Oh, there we go. Okay. Now it's going to mess with me. Okay, this is what I was just going to try and explain a little bit and show just a little bit of the toroidal fields. So if you got the 2 star fields sitting above you, and these are, north, south, the same thing is, you can see my map down here. This would be the North Pole. This would be the South Pole, celestial equator. This is your analemma going through. The red line is the celestial equator. As it goes across through the analemma, it makes its analemma symbol. As far as this would be what you would see in the north. Now I flipped it on its side and put the exact same line in the same place on this, and then overlaid it over 2 toroidal fields that I believe how it's happening above, and you can see how the analemma runs. I've got 2 different analemmas running through here, but you can.
Yeah.
I'm just going to show it. You can see,
Oh,
and
okay,
they
so it
both
switches.
they fall through the center of the toroidal field, no matter which side it's on. It's always falling through the toroidal field, down through. When it's charging up, when it fully charges, it falls down through and then falls down through. It's always in that fashion.
Yeah, and it's not exaggerated. I mean, people might get the wrong idea that it's going through these big loops to go above, up and around the toroidal field. But this kind of shows it's more of a, it's closer. It's a tighter. It's not as tall as the illusion of the graphic shows on the sides there.
Well, you have to understand too that this toroidal field is a toroidal field. This is an object that's charged up, that's held within the toroidal field. So if it didn't have charge, it would be all the way out here. It would be way up here, but it's not. It's held within the toroidal field in the space that it's supposed to because of its charge. The same way here. Even though it's fully discharged, you can see it's going into the very outside of that thing. That's why it gets bigger here. You see how the analemma is very skinny here and very tall here compared?
Right. Yep. It's a
Okay.
tighter loop. It's a
Well,
tighter
I
loop.
didn't do anything different. That's that image. That's all it is. Okay. Well, that right there is because of it literally pulling away because there's less charge. It goes further up on that toroidal field because it's less charged. The more charged, the tighter in the center of the toroidal field will be, the closer to the pole it'll be. The same way. So the further away it is here, it's going to be, the less charge it is in the south, the far higher and lower it's going to be through its circuit. The more it's charged in the north, it's going to be tighter as far as tighter. Not like it's not going to get close. It's not going to get closer to here. It's just going to get tighter in the magnetic field.
Gotcha. And you were saying that
Do you
you think
understand
that, yeah, I do. I get it. I hope people are understanding what you're talking about here. And the sun itself, you think, is actually made of something, and it is actually, in a quantum lock almost type with these toroidal fields, and the timing's
Yeah.
perfect, right?
Yes.
And you were saying
I
that you
believe so.
think that that things kind of do circuit around the sun, and like certain planets, right, that circuit the sun.
So if you look at the sun with different spectrums and like magnetic spectrums, look at it with, they're not what would you call metal detectors or nothing, but they're spectrum analysts and stuff like that. You can see that the sun is an object and it has electromagnetics coming off of it in the same way that we do off of our poles, except it's not accepting. It's not what is it, of a low or a very soft force. This is a very high energetic electromagnetic field being pushed off, and you can see that it's not north and south. You've got north and south all over this motherfucker.
Interesting.
You see that?
Okay, yeah.
Okay,
Wow. So you're
that's
saying there's
just the
no
sun.
polarity? Are you saying there's no polarity to the sun?
No, there is polarity, but the polarity is everywhere. This is not. I don't know how to describe this any more other way than this. You see that going on
right there? Oh, I went too far. See that going on right here?
Yep.
That's not fire. That's not burning and fire. That is
A discharge.
electromagnetics shorting out electromagnetics that's pushing out plasma and ions at rates that we don't even have any concept of knowing. When they tell us M3s and S-class flares that are moving at 120,000 kilometers per second, they don't have a fucking clue what they're talking about, dude. Some of these things are moving backwards and forward at the same time faster than you can measure it. It's
Right.
electromagnetics. It has nothing to do with
Absolutely.
burning. And there
Yeah.
definitely is a solid, what I think, I don't know exactly what it is. I'm not going to say I know exactly. I think it's iron and tungsten to some point. There probably has to be other things in there, but definitely iron and tungsten to make it glow in that exact fashion, that color, with this coronal ejections. Because this means there's a band of cool. That's not hot. That's coolness when you see those flares jumping up. That means that the electromagnetics have pushed away whatever the heat is from the opposing or the whether it's positive or negative. That's the cooling effect. When you see those things flip out like that, it's a
Yep.
hole opening up and letting coolness out.
Right. So kind of like regulating itself, like it's gotta keep everything going, and that's part of the process
Balancing.
of it. Yeah.
It's balancing. Yeah,
Balancing
exactly.
itself. Right. Interesting. It's got its own system,
Yep.
and then as far as other things running around the moon, like you were saying, Jupiter and Mars or Venus are in kind of a tidal lock of their own with the sun.
Well, not Venus. It would be so the
Jupiter.
only two that I know. The only two that I know of for sure are Mercury and Mercury and Venus.
Yeah.
They definitely are with the sun. They are locked with the sun. They move in their analemic cycle. They move with the sun, not by themselves. So Mars, I'm not positive about, but Jupiter, Saturn, Uranus, Neptune, Pluto, and the sun move their separate own analemas. They follow their own analemic cycle, whether it be 1 year, 247 years, or whatever. But Mercury and Venus circle around the sun and do their analemas with the sun. So the Mercury will go around the sun 3 times in 1 year. The sun does its analema, so then Mercury actually does 1 analema a year.
Mercury and Venus both only have one analema a year because they stay with the sun, which only has one analema, or
But
one crossover.
but they don't have an analema because you cannot get an analema out of Mercury or Venus.
Oh, okay, interesting.
Because
But they transverse from the south to the north with the sun.
with the sun. Yep.
Mm-hmm. Interesting. How is it they were able to create the illusion that all these planets are, in orbit around the sun, as well as the Earth we stand on being a planet doing the same? I mean, of course, it's just reverse engineering the mathematics, kinematics. You don't have to, go into how you think but it's interesting they were able to create that illusion with observations by making it perfect circles, and actually they're elliptical.
Well,
They show it as perfect circles. And
you could only have one or the other. It's either the sun's going around us, over the top of us, or we're going around it. It's either the stars are moving around or we're moving through the stars. You can't have it be a spider web of octopus being thrown in there. You got to have one or the other. That's
well, of
why
course, yeah.
they pick the opposite to be the inverse of what it was, and to push as much of our scientists and as much as our technological advances to be pushed under that, whether it be true or not, but be pushed under that auspices of it being a ball or under a conical or a spherical projection of the stars, a spherical projection of our universe. Whereas we all know now, whether you are a baller or not, the universe is flat. There is no There's no question in any scientist's mind. The universe is a flat fucking construct. There's no way around it. So
Well,
it just
that's
it
one
goes
of the
crazy.
things people bring up a lot is this whole idea that they've figured out that the universe itself is flat, which you'd think would be a contradiction to the idea that everything coalesces in this ball formation, but that the universe itself doesn't signify that whatsoever. But but yeah, the reverse engineering, the kinematics versus the dynamics, everything works dynamically with the stationary Earth with an absolute reference frame, and without that, I mean, the relativity is relativity retardation, and that's where and you talked about the scientists and all the people that they get into their fields of study that reaffirm the idea we're on a ball, flying through space. It's amazing. I mean, it's amazing. It's the perfect illusion. Hats off. Slow clap. It's the perfect illusion for what we're seeing here. The magnetic field it lends itself to that idea, and so many things about the dynamics or the seeming dynamics might work with the ball idea. Just reverse all of it and make the sun the center. But it's just interesting with all the variations that all of these things go through, and only Venus and Mercury, as far as you can tell, circuit the sun. But they were able to convince everybody everything's circling the sun, which it took a lot of brilliant minds to do that. I don't think they actually believed they were on a ball. They had to know they weren't on a ball to do the mathematics and get the kinematics to work out to give us the illusion that we're not the center, that the sun is. I mean, you can't just be under some kind of idea that you're flying through space without the dynamics to affirm that to begin with, gravity to begin with, to have it all seem to work in the way that now they've concocted everyone to believe in. But I'm rambling. I wanted to get to the point that the rocket scientist is the perfect specimen. Because he's smart enough to build the rocket, he just doesn't realize, he's not wise enough to realize that it goes to space. It doesn't never goes to space. Is what I always
I
say.
don't think that's.
What
I
do you
think they
think?
are smart enough. But if you were, if you had went, and this works for everything as far as how I look at it. If you went your entire life uh, training, either under the belief or under the thinking that the Earth was a ball, and you were going to train to be a rocket scientist or whatever it may be, maybe an electrician or an uh, electrical engineer, however you want to put it, that somebody that might need to be making some of the connections for the rockets and the payloads and things like that, or the satellites. Just think about that. You've spent, let's say it's even just 10 years of your life training for it. Now you've finally got to be able to get the job and do the stuff, and you're not telling people it's a ball. You're not doing all that. You're just making an equipment or a piece of something, whether it be technology that is involved in going into space that they're telling you, and you're getting paid whatever it is, $100,000, $200,000 a year, and you figure out there's no fucking way that this shit I'm doing is going to do what they say that is going up there. It's got to be used, but not in this fashion. Are
Right.
you going to fucking go up and say, I want you to take away my $200,000?
Yeah, exactly. Once
I
they're
want you
once they're golden handcuffs, right? Because once they're locked into that,
yeah.
and if they ever do realize it, now this gets to the point I think I was trying to get at earlier about the international date line that you can see there running north of north and south of south, and how that still allows you to go east to west, left to right, the same way you would on a ball, right? You were saying that the
Right.
people that work with satellites, because you just mentioned people that put satellites into orbit or have you know very intricate knowledge of how satellites work would have to know that the way that they change the time with the international date line when it's the summer or winter solstice. What is it that would tip them off that it works this way rather than on a ball?
The cars, the way that they're putting it up there in a certain location. So if they're putting these things up there, I probably shouldn't even be talking about this, to be honest with you, dude. But so if they're putting it up there in a certain location, so you know that you're going to run let's say Starlink, and you want it to be able to hit North America, you got to have 13 of them at least, most likely 26 for the circle, the whole circuit, right? Well, that circuit is going to be a certain charge, let's say 2,500 amps or whatever the fucking case may be. I probably shouldn't even be talking about this, to be honest. So if it's at 2,500 amps, then you're going to have all of these satellites that are at this exact latitude at 2,500 amps charge on the outside. If you need it to be at 12 or let's say 40th parallel, you're going to have to, in the north, it's going to be more. So you'd have to be at 3,600 amps or whatever the static charge is on the outside of the item that you're sitting up there going in this circuit. And if they want it to change, it's got to discharge or charge depending on where it is in the north. If they want to change to the fucking south, if they have something, it has to change past the threshold of the celestial equator. So whatever is the half charge of that will get it down into the southern. So if there's anybody that's dealing with satellites and they're charging these things up, they have to have a certain charge on the outside of whatever it is, the satellite, the Starlink, the fucking spacecraft, whatever they're saying they're putting up there, and it's actually moving up there at 62 miles above the surface of the plane of existence. It has a charge, and that charge dictates where in the plane it's going to be, where in the magnetic field, what latitude it's going to be at.
Gotcha. Yeah, so it might be only the people that would be in charge of charging it, I guess, or making sure it has the right charge to be in a certain area that would
Controlling it.
fit them.
Yeah.
Yeah, okay.
Yeah. The
And a
people
lot of
who
the people,
control it, and you wouldn't have.
most of the people are just getting a reading from a screen. They see that they see they could even look at this as they may even have a chart that looks just like this, with all of it just like you have it, that shows where the satellites are, and they think they're looking at a ball Earth.
No, theirs looks. We really shouldn't be talking about this. Theirs looks like a flat linear, and it's got the waves. It's got the oscilloscope waves.
Right.
So that's how they see it. They see it as in a wave that it moves across like a Pac-Man. And when it gets to here, it shows up over here.
Ah, okay, gotcha. So this is probably
And as it
partly
moves,
where the Pac-Man idea
as it goes
comes from.
across,
Yeah.
as it goes across, every time that it goes across, it moves 15 degrees. Or I'm sorry, no, that's wrong. It moves 60 degrees over. So the next wave will either be 60 degrees past it this way or 60 degrees past it this way. So you get the oscilloscope toroidal field that ends up being made as it goes through. You see what I mean?
So they're utilizing the magnetic field that we see the stars and everything else running on, the sun and everything, the circuit, right? So they're utilizing the way that above a certain latitude, things get in this field and start to run on their own, almost just like they say it does with orbiting, right? And that's why they can say it's falling, because it's in a fluid motion. And the only explanation is if we're in space and we're on this ball, we must just be, everything's just falling around us, even though we're going 67,000 miles around the sun. The sun's dragging us along at 500,000 miles an hour. 12 million miles out of our original space and time coordinates every single day without any kind of parallax to the stars or any of that, because they're infinitely far away. I mean, it's one after the other of these stretches of the imagination and, concoction making that they went through that has people, like we were just trying to get at a little bit, with very scientific minds and very, intelligent brains, now completely retarded, but at the same time saying everything that they can confirm from the data they're being shown, because that's the system that was created to give the illusion and even make people money by going along with kind of this illusion of the space and all. I mean, this is tipping a lot of apple carts over. So how many things we should say about a lot of things is hard to even, but the what is it we say that
No, I was saying we shouldn't talk.
You can't put the toothpaste back in the tube, in the truth tube, because now it's all out in the open. We're just trying to figure shit out. You can't blame people for doing that.
No, I was saying that about the whole we shouldn't talk about this because it's kind of like I can't prove some of the things. I can't show you documentation. I can't put up the mathematics.
so it's kind of like woo woo or magic. You know, I'm talking about shit that
Oh, I
people
see.
are going to go, oh, what the fuck are you talking about? This and that. And I don't want
I
any of
thought
that
you were
associated.
Oh, I thought I thought he was saying, "Oh, this is top secret. We can't talk about this."
Yeah, that's what I thought at first too.
Yeah.
That's the interpretation I got.
He's like, "Oh, top secret. I can't share this with you. It's
No,
classified."
it kind of does seem like he was a little bit saying it that way, but yeah.
That's okay. I'm sure he has a lot of like, I don't know. He seems to express himself in different ways, I guess,
Yeah, he
with
has some
language, I guess.
military, like family military connections, and he had like some access to internet that had military access or something. So a lot of it, a lot of these things, and he actually used to work like way back in the day, like got a brain for that.
Yeah.
But yeah, he also agrees with some of the things that were given, like with like that sun image. A lot of flat earthers would be like, "That's a NASA image," you know. I think he kind of like accepts some of the stuff that seems like it's actual. And it could be. I'm not saying he's buying into anything, but yeah, that sun image and stuff like that. Like it's showing us maybe what's really going on. And then I think a lot of flat earthers are just throwing away anything that has to do with like real data, which I think is a even like some of the stuff we've looked into where we're looking at like some of the old PDFs of like Einstein's real papers and things that are actually showing you like what actually happened compared to like the misinterpretation or you know
Right.
reification interpretation of some of these things along the way that are the more like the pop psychology or like the common man's distribution of information we get. Anyway, this is interesting. Yeah, on his site, on his YouTube channel, he's got this, but he's showing you here. These are satellites. Okay, these are like what real satellites. He's got a night camera vision that he's using here, showing some of the stuff in the sky that's floating around. I mean,
Yeah.
there's no
Yeah.
question. There's
There's
stuff
plenty
up
of
there.
stuff up there. Oh, there's tons of
Yeah,
stuff. You just can't really see it because it
yeah,
all kind of blends into the background, and you know, some of
yeah,
it's small, some of it's big, some is fast or slow.
yeah. And I've seen a lot of people like want to just jump on like they're UFOs when actually they're just satellites that they actually use. Maybe who knows? Some of them could be outer ponder satellites. That we have no control over. But we talk about that here. If you want to play it?
You mean like stuff that orbits around other land?
Well, no, just like even the stuff in our sky could be like not us.
Gotcha.
Yeah,
Like not China, but like green alien or gray or
yeah, like
whatever.
all the outer ponder tech that they like. We talked about the
Right.
idea that like the ISS was that um, Dark Knight. The Dark Knight satellite that they
Yeah.
used to talk
Yeah. Yeah.
about.
Yeah.
And now, if you look that up, it's like all conflated with like this UFO alien interpretation. But I have a friend that was in the Navy, and he was kind of aware of like some of these things as far as like what they were getting readings on. And he said the exact day that they stopped gathering information on the Dark Knight satellite is the exact day they claimed that the ISS was deployed. So whatever they were calling the Dark Knight satellite could have always existed, and it could be something that they didn't know. It may be an outer ponder surveillance thing that has nothing to do with any of our tech, and they've always monitored it. And since it was up there already, and it's still going just the way it always was, now they're calling it the ISS. It has nothing to do with anything that we did. Interesting idea, at least. But yeah, he seemed to know that that was like the timing on that. We stopped talking about the Dark Knight satellite and started calling it the ISS. Is the idea possible? Or like even like Starlink, whatever Starlink is. Well, we talk about that.
Mhm.
You'll see. Like they could have just said that it was Elon Musk when it was just something that they didn't have any control over either.
You see that are not moving
Yeah,
are
our
stars.
Gotcha.
The ones that are moving,
What do you think about
Like that
Solar
one?
Warden? New perspective.
Satellite.
that is a spy satellite.
Spy satellite. I'm sorry, what was that? In the shape or
That
something?
is a government satellite right there. There's no other way
called
to
Solar
describe
Warden?
it other than that. It could not be, but
Oh, I'm not
just the
familiar.
position it's going, that's going from south.
Send me a DM.
So, Solar Warden? What?
It's all good.
What are you talking about?
Put a link in the chat.
Oh, okay. Should I watch it or?
No, he was just asking if I'd heard of it, and I said whatever it is, put a link in the chat.
Gotcha.
South to north. I shouldn't even be doing this, dude. Never mind. This
Right?
this is
Espionage.
I'm just saying, if they're moving south to north and north to south in that fashion that are that big, so there was a shooting star, but you can
I'm
see
tuned
how
into a
big it
lot
is, how
of
bright it is compared to the
ex-military
other stars,
whistleblowers
and this is 4:00 in the
that are
morning.
hitting a lot of
Like that
similar
one right
notes
there,
on the topics you're bringing up, perspective. So
right? That's not Starlink. It's
Can
too
you tell
big.
from the okay, so from the shape of it and the size of it?
Yeah, it's just too big for it to be. Like here, I'll go ahead and I'll speed it up to the really good, the parts where there's 4 or
Ooh.
5 of the
The
non-Starlink
really good
ones.
parts.
Okay, there we go. So right here in a second, you're going to see them coming up from right here. And there's 2 coming up here, 2 coming down here, 1 coming up over here, and 1 over here. But the big ones, hold on, we'll just wait for them to. Oh, here they're starting to go. You're going to see 1 here, 1 here, 1 here, 1 here, and they're crossing different. You see that?
Mm-hmm.
Okay,
Yep,
those
so
are not Starlink. There's too many of them close together. They're both not on the same path. These 2 are going to pass each other. These 2 as well. So they're not on the same circuit. They aren't set up for a cylindrical, and they're crossing their paths over. They're too big to be Starlink, so there's something other than that. They're most likely going to be the Chinese Starlink or Skynet, whatever you want to call it.
Yeah. So and these are definitely not on balloons. The other thing that seems to keep lingering around the flat Earth lexicon is the idea that there's nothing up there even circling. These satellites don't even exist, and some of these other crazy notions that people keep repeating. But these are real satellites.
I just linked you 2 guys, 2 channels. It's just their most recent videos.
Orbiting in the way that the ballers,
Perspective.
propaganda.
It's Michael Jaco and Ismail Perez. They're both for sure part of a either an intelligence psyop or some sort of a whistleblower campaign.
There are balloons out there, though. There's no question.
Yeah,
Another guy that I've been
no,
trying to share, but I
There's
think it's
both.
kind of
Yeah.
a little too deep. Unless you already
There's
get the rest of it.
there even are Zeppelins still out there. You
Yeah,
can go
we
find
can't
them.
hear you over this, so just bring it up
Still
afterwards, maybe.
on what we call it, Google Earth.
You want me to take a break from this video? You guys can chat.
No, it's okay. Just bring it up afterwards, because otherwise we won't go back to it.
All right.
In Nevada, there are many Zeppelin programs still out there, but the high altitude balloons that you're seeing aren't Zeppelins. They're not anything like that. Anything that has any of those equipment type of satellite equipment or imagery, they're on a next level type of a balloon. They're not going to be just like anything you've ever seen or going to see. They're going to be up at 70,000, 80,000, 100,000 feet, and you aren't going to see it unless you have a P900 or a telescope.
Or night vision. Yeah, you have to have night vision. Right?
I actually got. Huh? I'm sorry.
The night vision, like you were just showing, you have a night vision camera or a night vision adapter or something like that.
That's actually a third generation digital night vision. It's the Aurora night vision, and yeah, it just allows me to record. But you have to do a little weird things to it to saturate it out so it can see, because it's not meant to do that. It's meant to show you night. And I mean,
Yeah, right.
you're
Going through the forest.
you're doing weird things to it.
Yeah.
But yeah,
Well,
that's just
also
that's just night
touched on,
vision.
that reminded me of something that I wanted to ask about, which was you were the what do you think that they're used for? Mostly surveillance, or are we getting a, because the whole idea that there's a signal going all the way up there, coming back down to give me TV or phone service and that kind of stuff. Would you say that some like what the undersea cables, the whole narrative on both sides?
Skynet. I mean, if you want me to just say it, I mean, it's
Yeah.
total control, all data and information, whether it be visual spectrum, electric spectrum, or magnetic spectrum. They have everything you could possibly want to record visually, sound, electric, data as far as radio transmissions up there. And it's not just one. Like I was showing you, it's not just Starlink. It's not just Skynet. It's not the government that has one. The government has two different systems up there. One is called a black op, as far as off the book one. One's on the books, and it's with Starlink. The one that's on the books is with Starlink, and then Starlink has their own neural network as far as up there, and then China has one. They have over 120,000 motherfucking pieces of equipment circling around our globe, and you just saw 72
Or
of
globe.
them.
Wait, you said globe. Don't say globe. Sorry, go ahead.
Oh, I'm sorry. Above the fucking magnetic field of the plane of existence that we live on. I'm just saying that they have over 100,000 things sitting up above us. Okay, and that's what we know of. That they tell us of. And if you go outside and go and look with your naked eye, you're going to see about it. Probably 1/5 of what I can show you with my night vision. But I'm down to, or up to, let's say, in 4 minutes, I'm getting about 100, maybe 120 things, lights moving across my screen.
Which is way more than what we even are told are up there, is what you're saying. Like there's way more
No,
things
we're
moving
told.
around
Okay,
that we
so
even have access to know about.
So even if we're told that there's 100, because they tell us there's 100,000 pieces of equipment that are live, that are usable piece of equipment that they have to have for everything to work the way that it is.
Mm-hmm.
Okay.
Right.
That's not all that's up there. There's what is it? Every day, it's like 4 Starlink satellites either burn up or go out of their orbits and are tumbling.
Right. Interesting. I didn't know that.
So now, what about the shit we don't know about that they won't tell us about?
Yeah, exactly.
So that's what I'm getting at. Okay.
Yeah.
Now let's get into
complete
outer
surveillance.
ponders, aliens.
Yeah, there could be even outer ponder technology up there that they aren't controlling. Like you even played with the idea that maybe Starlink is something they didn't do, but they had to take credit for it. So they claimed it was Musk, but it might even be something that we went out of our pond that's doing that. Is that what you're saying?
Oh, no, I was saying that. Well, yes, I mean, that is kind of what I'm saying, but I was saying those things that you're seeing that are launched, like when Musk says, oh, we just launched a new satellite that has 28 different fucking nodes of the Starlink. Starlink is not that bright. That's what I'm saying. If you go out and you find Starlink and you find a Starlink satellite, they are nothing like those string of pearls that you see that when they say they launched them. So I'm thinking that they're using, not that they're saying that they're doing it, but they're saying, oh, we just launched Starlink, right when they know something is happening up there to where we're getting these string of pearls in the sky. Because you've seen it, right?
Mm-hmm.
You've seen the string of pearls, right? Okay, that's nothing. That's nothing what you see in the sky after Starlink goes around. You don't see a bright, huge, bright fucking thing going across. That's what I'm saying.
So they're
They're not
kind
the
of
same.
making like a baby mock version of the same thing to say that, so that they can almost have an excuse for the things that they can't explain.
Well, I think it's this. I think that the government made the same way that they made up all kinds of other people. They made up that Elon Musk is the richest man in the world that controls and does all the programming and all the engineering for all the Tesla and all the fucking PayPal and everything else that he's ever had his mind involved in, and Starlink and fucking going to Mars and all this kind of shit. And he is pretty much the Epstein. He is the fucking fall guy that's gonna be the bullshit, because he's not as smart as he is. He didn't come up and buy and I'm sorry, he did buy. He didn't build all these things. He just bought and took and coerced. And he's a fucking goddamn ketamine addict. The
Right.
motherfucker can't walk in an interview. He can't not look like a fucking drug addict doing Twitch
Yeah,
and fucking.
he's perfect. He's the perfect front man. He's the perfect front man because he can say enough that makes him like seem like a mad genius almost if he's not on point. It's just because he's so smart that he's not able to socialize, and I think they even admit he's got
Yeah,
Asperger's or something.
yeah, Asperger's, and what was the other thing they said? Well, he's addicted to ketamine. That's the
Yeah,
other fucking thing. I
right.
mean,
There's a weird combination, right? Yeah, I bet they're not very good for each other. Those two things. But
but it doesn't matter.
he's a
The
front
whole
man. He's
point
a
is
funnel. He doesn't come up with anything. He's just the person that they say comes up with the things, and they funnel the money, and probably the distribution of all that supposed richness is not at all focusing on what he wants to do with his money. It's what they're doing with the pot that they all dip into, probably.
well, it's like this. Do you honestly believe that the United States government is going to give half a fucking $1 trillion to Elon Musk and Starlink and fucking SpaceX for not to have control and their own back fucking system? I mean,
Yep, it's
like
crazy.
they don't have. I mean, seriously, it doesn't make any sense how we would have no NASA. No, NASA doesn't take anything to the International Space Station, whether you believe there's an International Space Station or not. I know there's not. I'm just saying, whether you believe there's one or not. They stopped sending shuttles to the International Space Station, what, 10, 12 years ago? I mean, it's like, so they don't have any say in the delivery of our people there. And now it just everything is set up to make it to where, oh, it's all plausible deniability. Oh, we don't know anything. Oh my god, and this and that.
Yeah, yeah.
It's
Especially
not.
you got
It's
this
not,
guy. Yeah, you got Elon running it. Yeah. Anything's possible because this guy is just like off the handle, just doing all this stuff where he's going to be a trillionaire, and he's the perfect front for all of these things. Now, real quick, because you said there is no ISS, you do think there's an ISS type thing up there that people can find in their little app and actually see that looks like what they say it looks like. Of course, you're saying there's no ISS with people on it up there.
yeah. No, there is an object that is the brightest thing in the sky. As a matter of fact, it's one of the brightest things that you'll see moving. Not like it's not brighter than the moon or brighter than the sun. I'm saying if you're looking up at the night sky and you see what they consider the ISS coming across, it's really bright. But
Have you
there's no
zoomed in
fucking
on it?
people.
Have you ever zoomed in on it to see if it looks like the shape they say it looks like?
I have. With my P900, I've done my best, but I'm not on a orbital, or what do they call it, an elliptic tripod, so I
You don't
can't
have the
follow it
mount,
as.
the fluid mount.
Yeah,
Yeah.
I am so the times I caught it, it was coming at me off of the horizon, so I didn't need to so much have that. But there was no ISS. It was a light, a shape of a light. There was no ISS that I saw.
It's like a big satellite almost, the way it runs the circuit, right?
Yeah, and that's the other problem with it too, is so if you look at it, it doesn't run any faster. and it doesn't run any slower than anything else that moves up there.
Okay. Well, there's
You see what I mean?
like UFO Lou shows a bunch of stuff like zipping around and changing direction. What do you think all that stuff is?
I've never seen any of it changing direction. They always keep exactly on. There's so many of them that it looks like they turn, but I've never seen them change direction. As far as the ones I've recorded,
I wonder if it's part of the illusion of it going around the bend of a field. You know what I'm saying? Could you ever get that? Like where it turns a corner in quotes, but it goes in a circular fashion around one toroid or another?
The stories are actually pretty cool.
Give you the illusion
no,
of
the only
direction?
I couldn't see that happening. The one thing I could see happening is the same way that you're looking at the field here, and like if you're going around the latitude, if they were able to figure out how to sling it around and follow the longitudes, to where the circle's still a perfect circle. So if you're at here, your opposing field would have to be here, right? You would have to be on this exact field because you're on this exact field for that perfect circle. If they were able to figure out the charge, maybe an alternating current, or that they were able to get the motion of it going, and then they alternate the charge when it crosses here to make it hold that certain thing and maybe charge it up. I don't know. But that's the only thing I can think of, is if they can get that opposing, instead of following the circuit like the sun and the moon and the stars do, if they could use a slingshot, almost like almost like bouncing off the magnetic field. They're bouncing, boom, boom, boom. I don't know. I have no idea.
You were saying
I have no idea.
You were saying something about, since you're talking about blasting off, you were saying something about the when they launch rockets, they always are aimed in the same direction or something like that.
Yes, sir. Yes, sir. Every launch, no matter who it is, no matter if it's the fucking United States, China, all of them. It does not matter. This is where they launch every single time. If you look at these star patterns, and this is a shuttle launch. I think this is from 2004. Maybe it was 2002. I really don't know exactly what year it was, but this is a shuttle launch. So this is before they canceled the shuttle launches, and you can see this is the north, this is the south, and this is where they launch their rockets. Whenever SpaceX launches their rockets, they don't launch them over here. They don't launch them over here. Always directly at the celestial equator.
Wow. That's why Florida is a perfect spot to do it from. Right?
Yeah, I would think so. You know what? It's not that they have to. You know what I mean?
Right. You're saying that there might be something more to it, like they're trying to get out of the pond or something like that.
Oh, no. I'm saying there might be a reason why they're doing it for the mathematical equation. So if I didn't launch here, right?
Yeah.
Okay. And my charge, or whatever the case may, let's say I'm stupid and I'm a fucking retarded, and nobody thinks that there's ever any charge on anything, and this isn't magnetic or whatever, and they launch whatever it is to here. This is the balance. This is the center between these two fields, whatever it is, whether it's of two rivers coming together, whether it's two stars coming together, whatever it is, this is the center. So if they're off even an inkling of where their charge or whatever their buoyancy or whatever they're trying to get to make that thing or whatever they're shooting up there isn't right, it would be like launching into a headwind of 150,000 miles an hour, or launching into a magnetic field that was exactly 180 degrees opposed to you, and you would go, or you'd go, instead of actually, if you were going to the middle, you would just equalize between it until it would pick its own point.
I see. So you're saying that would you, first of all, would you think that some of the accidents are happened because they didn't do exactly what you're just talking about, like they didn't have the right angle or whatever it is, and that's why some of them explode? or crash?
No, I think they exploded because they didn't understand the whole concept of what the fuck they were doing going at those types of speeds in the atmosphere. And they were trying to make it look like heat shielding and all that. They didn't have to do any of that fucking shit. They wanted it to be that they were doing it. It's not like the shuttle was up there circling around in the magnetic field. The shuttle went where the shuttle went, and it went to fucking South America.
Oh, okay.
When they brought it back, they loaded it up on a motherfucking plane and then dropped it at 40,000 feet and let it ride into fucking White Sands.
Oh, okay.
You know that's how they transport that thing, right? On top of a 747?
No, well, you mean when they drop it into the ocean, or
No. I'm talking when they transport the international. The shuttle, the NASA shuttle. They would transport it on the back, a 747.
Yeah, you've
when
seen
they would
pictures
test,
of that. Yeah, right.
when they would test it, they would test it by releasing it off of the back of that 747 to test landing it.
Ah, okay. Interesting.
If you go to South America, there is like 4 or 5 major, I shouldn't say major, but there's 4 or 5 shuttles that have crashed there that were literally, I don't know how they figured it all out and did it all, but that's where they would launch those things to. They would launch them straight up to the celestial equator from Cape Canaveral and land them in fucking South America. Just like a rocket going up to whatever it was, 61, 62 miles.
So it's like the South American graveyard for the shuttles. And
whatever they couldn't,
has this caused problems, like right into the land? Like, have there been like people killed by them or that kind of thing?
No, it was that people were finding, the discarded fuel, the big
fuselage.
Yeah, the big. Right, they were saying they were circling up around the fucking Earth, and they were going to use them to make hotels or whatever. Remember that?
Right.
Okay, well they're not. They're sitting in South America.
Gotcha.
That's what I'm saying. People were taking pictures of them and talking about that was 20, 30 years ago though. That I don't even have any of that shit.
Well, when they show them now, like they show the stages where the fuselage or certain sections of it drop off. Like where's all that going? That debris that just
in the ocean,
just lands in the ocean. Okay, and they're usually going out aimed west, pretty much. They aim it, and they. It's funny because the whole idea is that it has to go around the Earth. That's why we never see it go into space straight up, because it needs to use the gravity, the pull of the gravity as it goes around the Earth, right? Which is the kind of another way of explaining this magnetic field interaction that it could be riding on, right? You think it ever does that kind of thing? Like it rides the magnetic field, these rockets?
Not the rockets, but the things that the payloads that they're sending up there. Oh yes, they definitely are. That's how they're getting them up there.
Right, the rockets, and then obviously there's no people on anything that they're shooting into space or any of that kind of stuff. But you think that a lot of this is actually serving some sort of purpose, maybe. Not that you need to get into the idea that they're trying to get out of the pond, but that's something you mentioned. But maybe like
well, now you're talking about
whether like censoring. Do you think they're collecting data with these things? Is that part of it?
Well, you're talking about 2 totally different things now. So if you're talking about what's up there, that what we've put over there, let's say up till the year 2000, most of all that stuff was weather fucking satellites or whatever you want to call them. They even had Balluna lights at that time that would circle in the weather patterns. They were actually opposite of the satellites. So they would do. Now they have the satellites, or what I'm calling the satellites. They're not in outer space. They're riding on the magnetic field that's up there. But there's multiple difference. There's one for Skynet, for the government's Starlink-like thing. Then you have Starlink. Then you have whatever the China one is called. And they all have a neural network, a grid of these fucking things sitting up here and a grid of them sitting down here. Exactly
on within this grid. Whatever the latitude and longitude you can see, they have a satellite or something circling within inside of that field. When you get outside of that field, so when you get to here or here, they can't do it. That field, or at least I don't know of any way for them to be able to go through the medium of, like you're saying, the ether, I'm saying whatever it is up there,
Yeah.
is the magnetic field ether. When they get out to these points, they can't hold it. There's nothing there. There's nothing for them to use to hold them within inside the orbit or the circuit above, within inside either the southern pole or the northern pole magnetic field.
Wow.
And there's multiple of them there. You have government, you have civilian, you have government, and then you have the mixed. The ones that you think are just, oh, they're just there to give us our high-speed broadband internet. Oh, bull fucking shit, dude. It's like I've said before. Nothing in this world is free, and when they're giving you something that costs trillions of dollars for $1 or $169 a month, or let's say it's $69 a month, you are the product. It's not this connection that we have that enables me to talk to you and everybody else around the world to be able to see us at one time. It's that we are the product. They are taking all of this information, the sound of my breath, the words that I'm using, the way you are looking at this image and going, oh yeah, that's kind of fucking interesting, or maybe it's fucking bullshit. They're all of that information, and that's the key. That's what they're doing with all this stuff. Has nothing to do with what you believe, what you're going to find out, what I'm going to explain to you that's going to make you think the world's flat, and that it looks like this, and you can use this star map to get to where you can tell your friend, holy shit, man, you've got a Cato above you and Doobie's over to the left. Look outside, man. I can tell you what the world looks like. It's flat. They don't give a fuck about that. They want to know if they can control every single data point that's anywhere along any of these coastlines, with inside of any of this place of existence. They want to control it and have total control. That's what it's for.
Total influence, give you the free TV or the, cheap TV, the entertainment, the access to the internet to, say whatever you want to say, or at least in some areas you can still say, like in America or wherever it is, that you can still say what you want to say and have freedom of speech, which is what this is all about. They opened the door with, possibly even rolling out flat Earth. I don't know if you want to talk about that, but we talked about that back in 2017, where it seemed like there was a game being played that they were allowing people to participate in, or even maybe having like people giving false narratives on purpose, and or just being like the Mark Sargent or whatever. That's whoever he is. He's just allowed to give people the information about the flat Earth because it's on the table for everyone to talk about, and it could be as innocent as that. But if the idea that they might have even rolled it out now, and then some people think that it was just this 10-year plan with, ending it all, trying to end quote unquote flat Earth as if it was a thing you could end, where it's just the reality we observe. And there's enough people that have figured that out now, where, the TFE thing, or the 24-hour sun, if you didn't figure this out, somebody else might have, just based on the idea that they've confirmed there's a 24-hour sun, maybe two poles then, because it doesn't work otherwise with the AE map, and maybe someone else might have gotten at least close to where you're at with this, possibly, but maybe they even knew that. Maybe they gave us the TFE or the 24-hour sun confirmation so that eventually they could tell us that it's a two-pole flat Earth, and we had to, lie to you because of the Outer Ponders Treaty, and how I talk about that. But it's just an interesting thing that this has kind of pushed the hand of anybody that has, common sense and is already aware that it's not a ball Earth, and there's a 24-hour sun, which kind of like leaves that two-pole flat Earth option as the only thing that works. And it's so simple when you look at it, like what you've done here with this, and it has to work this way. Not to say that you've figured it all out, but you've at least figured out enough to make this a useful tool. You were saying that this could actually be used by people for, navigating. Like this could be a useful thing regardless of what you think. If you're on a ball or if it's flat, it doesn't even matter. This is the way it works, and someone could use this to chart out where they are and use it for like a nautical navigation system, right?
Yeah, I think that's the main thing that this is going to. So, like I say, I don't claim that I know the Earth is flat, or that I'm trying to prove the Earth is flat. It is. That's not what I'm saying. I'm just saying I'm not trying to prove that or anything. This I can prove. This I can show you. This will save your life if you were out in a boat and you didn't know how to. You didn't have a clue how to navigate by the stars. I could.
No
You could
GPS. The
read.
GPS goes down, right? You don't have GPS. You need something to rely on, right?
Right.
Right here?
Or just things aren't going right. Your GPS isn't working correctly. It could be working,
Sure.
but it's not showing you where it is. Things just aren't working right. You don't have to go by a digital I'm sorry, not a digital, a graph or a list of numbers that you have to do trigonometry and have calculus and have an understanding of every star and what its name is and how it is. Whereas this literally go, you're going to know, am I in the Pacific? Am I in the Atlantic? You're going to know where you're at. I mean, you're not going to be that fucking lost. So you're going to be
Yeah.
able to go in just very easily, set the stars to what you see in the sky. Let's say this is the Big Dipper, and the Big Dipper is right over towards the north. You're just going to set it like that, put your graph over the top, do your readings for whatever star you're looking at, where it be Arceus, Regulus, Virgo, whatever it is. You're going to get that measurement off of here, and from that, you'll be able to triangulate exactly where you are down to. I'm good to about 100 feet. I would say 500 feet. I can get within, but down to 100 feet, latitude and longitude of where you're at, without having to have, like I say, any knowledge of the stars, all this kind of stuff. I could teach a 6-year-old how to do this very easily. And I think that's what's going to change it for a lot of people. Not that they're going to have to use it. Not that there's going to be everybody in the world's going to go, oh, thank God, equal one figured out how to do this. But fucking people that literally go sailing around the world, they will have this. They will spend the $100. I think it's going to be about $100 for this, all the 9 different things on top of it, and then for the map to be in a hard plastic polyurethane
As far as
condition
what
that's
you,
not going to.
as far as like, and that's just like what you could afford to with materials and time it would take for you to package this for somebody, you know, maybe 100. I mean, whatever it is that it would cost. You just lost your camera, by the way.
Did the video stop?
That's the end of that. That's the end of that short edit or long edit, screen record edit. But if he's right, I think there's some things you could check about, like some of the stuff he was saying. Like he's saying that forward corner, you know, east west, north south, cardinal direction, graticule. He's like, that's what they actually use for everything. It's not like they use the ball for anything.
Yeah.
So if that's what they're actually using practically, why would they make the graticule a ball to begin with, and then transform it into what they actually use? Wouldn't they start with what they actually use and then do the transform would be the ball, you know, the transformer, the coordinate system would be the ball after the practical use form of it, or the AE, which, you know, doesn't allow the same directions for the sun, but it still has the same GPs show up that could make you think you're still on an AE map with the sun showing up where it's supposed to be. It just didn't come from the right direction. But I'm surprised that more people haven't like, done some of the same type of stuff he's doing, because all he's doing is looking up nautical information, really. I mean, how many millions of flat earthers are there that are really taking, like, I mean, us, even we're guilty of it, spending like 10 hours a day talking about the topic without looking up some of the data, the technical stuff that maybe would have at least confirmed some of the stuff he's talking about by now?
I think there was a heavy, I think there was a heavy amount of censorship for a long time. So like people were more concerned about like getting the word out and a lot of people weren't concerned with the heavy research. And now it seems like, you know, I would say like the main push is kind of like out of the way. People have resorted to more research, you know?
A lot of people have left the conversation because of TFE. Not to say they went back to the ball, but they don't have as much fun talking about it because all a baller needs to do is come in and say, well, what about the 24-hour shot? You can't explain that on AE, man. And they don't have anything. They don't have anything to say because
Yeah.
you can't explain that on the AE map. So it makes you
Well,
lose the
it's made it
conversation
less
you were always winning.
competitive. It's made it less competitive. Like they're very lazy now, like very script driven. You know, they're really not
Well,
even able
they don't know what to think.
think
You
of the
know, if you have that
concepts.
AE map, if the 24-hour sun doesn't work with AE map, it kind of makes you stuck. It's not going to make you think you're on a ball again because you can't unrealize something, but it's going to make you feel like, I don't know what to think. I know it's flat, but I don't know how that works with the sun. But this gives an answer to it. I don't know why more people aren't open to this possibility, at least. I think he's pretty, I think he's close to right, if not, exactly right. It doesn't matter. But it
I
gives an
mean,
answer to the 24-hour sun. And people seem very resistant to the two-pole model, which actually gives a flat Earth answer for the 24-hour sun. Why wouldn't people be excited about it rather than resistant?
you know, I think people still think it's flat. I mean, everyone has kind of like made that concession, but at the same time, I think they feel kind of burned with this whole AE projection thing. I think people feel genuinely burned, and they're kind of like moving away from like the discussion, even though they still think, you know, the Earth is flat. They're just, you know, a lot of people were just kind of trusting what they, you know, what they'd seen and what they were being told, you know. And
Yeah, flat Earth has never been about a model. It's never been about the AE map, at least for
that's
me or
exactly
most people.
correct. That's the difference between this and the globe, is that if you take even one part of the globe away, suddenly the whole thing breaks apart. But flat Earth has never had a map, you know. We've never had a complete model, so like we're not missing anything. Like if that map doesn't work and we had to use something else, okay, whatever. You know, it's just another day.
Yep. It's not necessary to claim something that you can't confirm completely 100% because that's what they're doing. And we've always been wise about not trying to make claims, at least the people that know what they're talking about.
Yeah.
Making claims, that you can't confirm. Now, speculation has always been something I've loved to do, which is what leads to maybe figuring shit out way more than just like saying, let's just talk about level water nonstop only. So there's different venues for different types of approaches, which is good. You just have to appreciate everybody for who they are and what they want to contribute, as long as they're trying to be the best they can be.
All right, guys, group hug.
Group hug, but yeah, everybody needs to fucking get along. I was thinking about like what could possibly be like the best, like some of the things I say about like their reasoning for the ball lie, like I could almost understand if it is like he's talking about, like if we really can't get out of this electromagnetic area, or there are harder pounders that wouldn't allow that, or you would get killed, or if we're like trapped in a cage in a certain sense, I can almost understand why, they would justify the whole like, oh, you can go to space eventually, and all that, the sci-fi that goes with it, and the whole illusion, and the money laundering or whatever they're doing with the money. We can't control that anyway. So they kind of do it with like a wink and a nod, with like playing golf on the moon, and some of the impossible things, showing us the harnesses on ISS like they made a mistake. There's no way that's a mistake. They're showing that to us on purpose. So the whole thing's been a game, but not because it's a ball Earth. It's because there's like, you know, they're in control, and it's kind of like the kings that would come through with their, you know, golden throne or their carousel and like, you know, kind of flaunt their richness and their control over the peasants. But this is just another form of that same kind of gaslighting, I guess.
You know, I actually saw that map a long time ago.
Yeah, and even like the image that stuck out to me when you were asking about what's it look like without the grid. Like I'll post one that even with the way the ice cut like an apple, I remember seeing an ad that was an apple and it had all the continents in it that looked just like this. When I made it, I'm like, oh shit, I've seen that before. It had to be like I distinctly remember something where they had like an apple image, and inside the apple were all the continents, just like I have it drawn for what he was talking about, the way it should be drawn.
Yeah.
They've shown this to us before, probably a lot more than we will remember. But yeah, I remember like if you turn that to its side, I remember that distinctly, seeing the continents like that. And I was like, what is that? At first, I didn't realize it was the continents because it would look like an apple with something in the middle. That was cool last night when Nazi was showing. I put that on my channel where he was zooming in
Oh,
and
cool.
showing the way the bones were,
Yeah.
like the way like the penis bones and like
Dude,
the
the
way they were
octopus
broken up.
eye and then the copper
Yeah, like
mine.
there's no
That
doubt
was pretty
about it. There's
cool.
something like that.
That was
Like
pretty cool.
especially along the edges where you see like the different bones and the way cartilage actually works. Like what else could it be? It doesn't make any sense that that's everywhere like that.
Hey, you know, looking at this map though, like it really does make the case for Pangea. I mean, you can see how that all kind of like closes up in the center, you know.
Well, that's one of the other things, and one of the other edits that we didn't watch. He was talking about the tectonic plates and how they move, and he goes by, you know, some of that data being true as well. It moves 17 inches every year, the plates. And some areas they move more than other areas, but it fits with his the two toroids going, and that's the direction they move in. Like there's a transverse effect of the sidereal rotation and the magnetic electromagnetic flow in the way that the platelets move, and you can see the directionality of it. And and he goes along with that. That's where like you see the highest mountains, right at the area where you would expect, because the land's being pushed up. So it's a lot of these things that like we just like totally disregard a lot of the science that's actually being done or being figured out because of the ball interpretation. So it makes everybody blind to it once they realize that it's not a ball. But a lot of this is real information, and there's actually some kind of like quote unquote continental drift, but it's the platelets moving and causing some of these structures similar to how they're saying it's just not on a ball. I mean, the platelets would never work on a ball. It just never wouldn't work that way. They have to like work like horizontal to each other to have the subduction zones and all that. But yeah, the ring of fire is right around the continents too. Like you can look at all these areas, and that's where all the earthquake and volcanic stuff going on.
I just found this one. It's kind of cool.
Yep, very similar. But that's the two pole without the 33-degree correction. And you got New Zealand way down below Antarctica.
Okay, okay. I see what you mean. Yeah. Yeah, that makes a big difference for how it looks.
Yep, and how it actually is. There's no way New Zealand's way down there below Antarctica. But it makes a good straw man of the 2-pole map with that 33-degree correction. Like that once they moved the prime meridian, it moved all the continents so that New Zealand's way down there. And then you would look at that map or try to make it work with the way things work. You're like, oh no, New Zealand's not down there. Oh, that's because it's a transform and it's false. No, it's because it's the correct transform, but it's 33 degrees off, so everything moves, and it makes it look incorrect on purpose. Probably that's part of the reason they did that. I'm sure. Make a lot of sense, you know. Like, oh, we'll make it a little bit off, and no one will ever think this is the true map. But if they looked at it the way it's supposed to be, then it's exactly how we see it and how we use it. We can't show them that. We have to have this like cloak of our 33-degree wink wink prime meridian adjustment.
And I figured out stars. Then I started understanding. As soon as I pulled everything in together, the same way I did with the northern, and brought my maps together to make it to where it literally worked, to where my latitude and longitudes literally worked out in this fashion on here, to where things were where they were on the actual latitude and longitudes. I did the same to the bottom, started working, except for one thing. This. You see how New Zealand is here, Australia's here, and it's just not right, and things just didn't work right as far as with the movement of the sun coming around. You just wouldn't have everything working right. So that's when I found out the 33, because this is the map for before, without the 33 connection. Change it. Oh, I don't have it here. So then you go to the 33, and you see that everything moves out to where now New Zealand is over where it would be. You literally get the 3 hours of sun. It literally gets 3 hours of sunlight when this is in the apex at 23 degrees north. This gets an ambient or an actual straight 3 hours and 50 something minutes, or 3 hours and 16 minutes of light in New Zealand, like it should now. And all of these things started working out as far as the patterns of everything. Now I could just take the graph and move it. I mean, I didn't have to do anything but just renumber it to where now this is 0 and this isn't 0. And now it all worked. Everything worked out.